In the quiet of the human body, beneath the rhythm of the heartbeat and the rise and fall of each breath, there exists another rhythm, softer and hidden. It is the rhythm of communication carried not by spoken words or thoughts, but by chemicals known as hormones. These molecules move gently through the bloodstream, carrying signals from one place to another, weaving together distant parts of the body into a single, connected whole. While neurons speak with lightning speed and electric impulses, hormones travel more slowly, their influence lingering, shaping, and balancing. They are not loud, but steady, not forceful, but essential. Without them, life would unravel into chaos, as if an orchestra had lost its conductor, each instrument playing alone without harmony. Hormones are often thought of as something mysterious or complicated, yet at their essence, they are simple messengers. They are produced in specialized glands scattered throughout the body, released into the bloodstream, and then carried to their destinations. Each hormone has a shape and a purpose, fitting like a key into a lock on the surface of a cell. Once the key is turned, the cell receives its instruction, and the body's balance adjusts in response. It may be an instruction to use sugar for energy, to grow new tissue, to release water, or to rest and sleep. Each signal is precise, like a drop of ink spreading into clear water, small but transformative. This quiet system of signaling is known as the endocrine system, from words meaning to secrete within. Unlike exocrine glands, which release their products outward through ducts, endocrine glands let their chemicals slip directly into the bloodstream. Invisible but powerful, these secretions do not vanish quickly. They linger, allowing effects that may last minutes, hours, or even days. In this way, hormones create long, slow waves of regulation, steadying the fluctuations of life and helping the body maintain homeostasis, the stable internal environment upon which life depends. When you imagine the inner workings of the body, you might think of organs like the heart pumping blood or the lungs filling with air. But beneath those obvious movements is a subtler flow, one that you cannot feel directly. Hormones quietly ensure that when you eat, your body knows what to do with the food. They tell your cells to absorb sugar, to store fat, to release energy when needed. They whisper to your bones to grow strong, to your muscles to repair themselves, to your skin to heal when it is cut. They even guide the mind, influencing mood, focus, and sleep. Every aspect of being alive is touched in some way by these unseen messengers. The importance of balance cannot be overstated. The body thrives within narrow ranges. Body temperature kept near a steady point. Sugar levels neither too high nor too low. Calcium held precisely, so muscles can contract and nerves can fire. Hormones are the guardians of this balance. When conditions shift, when food is scarce or stress is high, hormones adjust the body's course, like a sailor trimming sails to keep a vessel steady against changing winds. Without them, even the smallest change could become dangerous. With them, the body endures fluctuations. With quiet resilience, it is easy to forget that hormones are not confined to a single place, but rather span across the entire body. From the base of the brain, the hypothalamus and pituitary gland act as a command center, sending out signals that direct other glands. The thyroid in the neck sets the pace of metabolism, influencing how quickly the body uses energy. Tiny parathyroid glands, no larger than grains of rice, sit beside it, carefully monitoring calcium levels. The adrenal glands, perched atop the kidneys, prepare the body to respond to stress or conserve energy and calm. The pancreas, nestled near the stomach, watches blood sugar and releases insulin or glucagon as needed. Even the gonads, The ovaries and testes shape not only reproduction, but also the very essence of growth, development, and mood. All of these glands, working together, create a web of communication that sustains balance through every stage of life. The story of hormones is not one of isolated actions, but of cooperation. Consider, for instance, the simple act of drinking a glass of water. As the liquid enters the body, sensors detect the rising fluid levels. The pituitary gland reduces its release of antidiuretic hormone, allowing the kidneys to release more water into urine, preventing overload. Conversely, if water is scarce, antidiuretic hormone increases, signaling the kidneys to conserve every drop. The body never leaves hydration to chance. Instead, hormones maintain a careful equilibrium. This same principle applies to countless functions, from regulating body temperature to balancing salt, sugar, and oxygen. Hormones also guide the daily rhythms of life. As morning comes, cortisol rises, nudging the body awake, raising alertness, and preparing for the day. As night falls, melatonin increases, calming the body and drawing it toward rest. These cycles, known as circadian rhythms, are synchronized not just with light and darkness, but with the body's own internal timing, a clock that ticks in harmony with the world outside. Through hormones, this rhythm continues even if one is unaware, ensuring that energy and rest alternate in balance. To think of hormones is to think of subtlety. They rarely act alone, instead working in pairs or in feedback loops. When blood sugar rises after a meal, insulin brings it down, guiding sugar into cells. If levels drop too low, glucagon raises it again, prompting the liver to release stored energy. This push and pull ensures stability, never letting one extreme persist. In this way, hormones mirror the balance of nature itself, where cycles of growth and rest, abundance and scarcity all contribute to a greater equilibrium. As you drift deeper into thought, you may imagine the body as a landscape, each organ like a city connected by rivers of blood. Hormones are the messages carried along those rivers, sometimes urgent, sometimes gentle, always purposeful. They connect the brain to the heart, the stomach to the muscles, the bones to the kidneys, creating unity where otherwise there would be isolation. In their absence, systems would fall silent, unable to coordinate. But with them, life unfolds in harmony. Even emotions, those intangible feelings that rise and fall like tides, are influenced by hormonal currents. The release of serotonin and dopamine affects mood and reward. Cortisol, in times of stress, shapes the feeling of tension and readiness. Oxytocin, sometimes called the bonding hormone, deepens connections between people. In these ways, hormones shape not only the physical but also the mental and emotional landscape, knitting together body and mind. Though they may be invisible, hormones leave their trace in every action of life. From the earliest stages of growth in the womb, when hormones guide cells to differentiate and organs to form, to the final years of life when balances shift again, they accompany us quietly, faithfully. They are both architects and caretakers, shaping the body and then sustaining it through the decades. Their whispers may go unnoticed, but their influence is constant. As this journey into the world of hormones begins, it is worth remembering that these messengers are not separate from you. They are you, part of the same living whole that breathes, moves, and dreams. Every heartbeat, every breath, every moment of calm is carried in part by their guidance. To understand hormones is to understand balance, and to understand balance is to glimpse the quiet order beneath the surface of life itself. In the stillness, even as you rest, hormones continue their work, guiding, adjusting, balancing. They are the quiet messengers of the body, ever present, ever faithful, ensuring that within you, harmony is preserved. 2. What hormones truly are. To imagine hormones clearly, it helps to think of them not as mysterious forces, but as natural messengers with a simple task, carrying instructions from one part of the body to another. They are chemical signals, released in tiny amounts, yet their influence stretches far. Unlike nerves, which send rapid sparks of electricity along well-defined pathways, hormones drift slowly through the bloodstream. They may take seconds or minutes to reach their targets, but their effects often last far longer. This makes them perfectly suited for steady, ongoing regulation rather than quick, fleeting reactions. They are not the language of sudden impulses, but the quiet speech of long-term balance. Every hormone begins its journey in a gland, a specialized tissue that produces and releases it at just the right time. Once secreted, it enters the bloodstream, the vast river that flows through every corner of the body. From there, it travels freely until it meets a cell, equipped to recognize it. Not every cell listens to every hormone. Only those with the correct receptor can respond. This receptor acts like a lock, and the hormone is the key. When the two fit together, the lock opens, and the cell receives its instruction. That instruction might be to grow, to divide, to release stored energy. In this way, hormones ensure that cells respond not randomly, but with precision, in harmony with the rest of the body. Although they are small, hormones come in different forms. Some are proteins or peptides, chains of amino acids, shaped in particular ways. These cannot easily pass through cell membranes, so they act on the surface of cells, binding to receptors that then trigger changes inside. Insulin is an example of this type, docking on the outside of cells to signal them to absorb sugar. Other hormones are steroids, made from cholesterol. These slip through cell membranes with ease, entering the nucleus itself, where they can influence the expression of genes. Testosterone, estrogen, and cortisol are examples of steroid hormones, altering the cell's behavior from deep within. There are also amino acid-derived hormones, made from single building blocks but powerful nonetheless, such as thyroxine from the thyroid and adrenaline from the adrenal glands. Despite their different forms, all share the same essential role, carrying messages and ensuring balance. The way hormones travel might seem inefficient compared to nerves, yet it is this slowness that makes them effective for their purpose. Nerves are like telegraphs, sending sharp and immediate signals to a single destination. Hormones are more like radio waves, spreading broadly, reaching many areas at once. Their signals are not meant to command instant movement, but to adjust the tone of the body, influencing metabolism, growth, and mood. When you wake in the morning, it is not a single nerve that makes you alert, but a gradual rise in cortisol and a decline in melatonin. When you fall asleep at night, it is not one sudden command, but the gentle increase of sleep-inducing signals, tipping the body into rest. What makes hormones remarkable is their ability to influence processes across great distances. A tiny gland at the base of the brain can release a chemical that affects the ovaries or testes, guiding reproduction. A gland near the throat can release thyroxine, which alters the speed of metabolism in muscles throughout the body. A gland on top of the kidneys can release adrenaline, preparing the entire system for heightened awareness and energy in moments of need. It is as if a whisper in one room can cause a door to open in another room far away, without any direct connection between the two. This capacity for long-distance influence is what makes hormones indispensable. The sensitivity of the system is extraordinary. Hormones act in such small amounts that even a slight excess or deficiency can create noticeable changes. A tiny increase in thyroid hormone may raise metabolism, causing weight loss, a rapid heartbeat, and restlessness. A slight decrease may cause fatigue, weight gain, and cold intolerance. The body avoids these extremes by using feedback loops, systems of self-regulation. When a hormone level rises too high, the gland that produces it receives a signal to slow down. When levels fall too low, the gland is encouraged to increase production. These adjustments happen continuously, often without our awareness, keeping hormone levels within narrow ranges that support health. The interplay between hormones and cells is not only chemical but also temporal. Some hormones act quickly, producing effects in seconds or minutes. Adrenaline, for instance, can raise heart rate and sharpen focus almost instantly. Others act slowly, with changes unfolding over hours, days, or even weeks. Steroid hormones that influence gene expression may take time to alter the production of proteins and enzymes within a cell. Growth hormone acts gradually, shaping development over months and years. This variation allows the body to manage both immediate needs and long-term processes, weaving together the quick and the enduring. Hormones also reveal the body's unity. They remind us that the brain is not separate from the body, and the body is not separate from the mind. When the hypothalamus in the brain perceives stress, it signals the pituitary gland, which in turn signals the adrenal glands. Cortisol is released, affecting the immune system, metabolism, and even memory. The experience of worry or challenge is thus not confined to thought, but translated into physical change. Similarly, when blood sugar drops, the pancreas releases glucagon, prompting the liver to release stored glucose. The result is not only physical energy, but also a restored sense of clarity and focus. In this way, hormones bridge the physical and the mental, uniting them in one flow of balance. To speak of hormones is to speak of balance itself. The word homeostasis, meaning same state, describes the delicate constancy that hormones help maintain. This constancy is not rigid. It allows for gentle fluctuations, small rises and falls that keep the system flexible. Body temperature, for example, may shift slightly depending on the time of day, activity, or stage of the menstrual cycle. Blood sugar may rise after meals and fall during fasting. Calcium levels may adjust as bones store or release minerals. Yet within all these changes, the range remains safe and narrow. Hormones are the guardians of these ranges, quietly correcting deviations, ensuring that balance is restored. Another way to understand hormones is to think of them as part of a symphony. Each gland is like an instrument, producing its unique note. The pituitary sets the rhythm, the thyroid adds tempo, the adrenal glands provide crescendos of energy, and the pancreas ensures the melody remains smooth. Alone, each instrument is incomplete. Together, under the direction of feedback and regulation, they produce harmony. This harmony is life itself. Not only the beating of the heart or the firing of neurons, but the steady background that allows growth, rest, reproduction, and thought to unfold seamlessly. Even though hormones may seem abstract, their influence is felt in the most ordinary experiences. The hunger you feel before a meal is shaped by ghrelin, rising to tell the body it needs food. The sense of fullness after eating is guided by leptin, signaling that enough energy has been consumed. The calm that follows exercise is partly due to endorphins, hormones that soothe and reward the body for movement. The drowsiness before sleep is carried by melatonin, quietly dimming the inner lights of the body. These experiences, familiar yet often unnoticed, are everyday expressions of hormonal balance. To know what hormones truly are is to recognize them as threads woven through every aspect of existence. They are not separate from the self, but integral, shaping both body and mind. They speak in whispers, never shouting, yet their influence is constant, profound, and essential. Without them, the body would lose its coherence, systems would drift apart, and balance would fade. With them, life flows in harmony, steady, continuous, and whole. 3. The endocrine system, a silent orchestra. Within the body lies a network of glands that rarely draw attention to themselves, yet their influence extends to every aspect of life. This is the endocrine system, a collection of organs that secrete hormones directly into the blood. It does not announce itself with noise or sudden force. Instead, it operates quietly, steadily, almost invisibly, ensuring that the inner environment of the body remains balanced. To think of this system is to imagine an orchestra, not of instruments producing sound, but of glands producing harmony. Each has a part to play, each contributes its own notes, and together they weave a seamless composition that sustains the living whole. At the very top of this orchestra sits the hypothalamus, nestled within the brain. It is not a gland in the traditional sense, but rather a bridge between the nervous system and the endocrine system. The hypothalamus translates neural signals into hormonal ones, a translator that listens to the body's needs and responds with chemical messages. These messages often travel to the pituitary gland, the small structure just beneath it, which is sometimes called the master gland. Though small in size, the pituitary has a vast responsibility. It releases hormones that control other endocrine glands, directing the thyroid, adrenal glands, and gonads to release their own signals. In this way, the pituitary sets the rhythm, guiding the performance of the entire system. The thyroid gland, shaped like a butterfly and resting just below the larynx, contributes to the tempo of metabolism. It releases hormones such as thyroxine and triiodothyronine, which determine how quickly the body uses energy. Too much thyroid hormone, and the tempo quickens. The heart races, weight drops, and restlessness grows. Too little, and the tempo slows. Fatigue sets in, weight increases, and the body feels sluggish. The thyroid is balanced by the parathyroid glands, 4 tiny nodules located on its back surface. These small players have an outsized role in maintaining calcium levels, adjusting them so that muscles contract properly, nerves, fire, and bones remain strong. Moving downward, we find the adrenal glands, perched atop each kidney like caps. Each has 2 parts, the outer cortex and the inner medulla. The cortex produces steroid hormones such as cortisol and aldosterone. Cortisol helps regulate metabolism, immune responses, and the body's adaptation to stress, while aldosterone maintains salt and water balance. The medulla, in contrast, produces adrenaline and noradrenaline, hormones that prepare the body for sudden challenges by raising heart rate, increasing blood pressure, and sharpening awareness. The adrenal glands are like instruments that play both quiet, background notes for everyday regulation and sudden dramatic bursts when the body faces stress. The pancreas, resting near the stomach, is unique in that it serves both endocrine and exocrine functions. Its endocrine cells form clusters called islets of Langerhans, where insulin and glucagon are secreted. Insulin lowers blood sugar by helping cells absorb glucose, while glucagon raises blood sugar by prompting the liver to release stored energy. Together they maintain a delicate balance, ensuring that the body has enough fuel without excess. This is an example of hormonal counterpoint, where 2 hormones act in opposition, yet create harmony. The gonads, the ovaries in females and testes in males, produce sex hormones that guide reproduction and also influence growth, mood, and body composition. Estrogen and progesterone regulate the menstrual cycle, pregnancy, and secondary sexual characteristics, while testosterone promotes sperm production, muscle growth, and deepening of the voice. Though these hormones are often associated with reproduction, their reach extends further, affecting bones, the cardiovascular system, and even brain function. They are like deep resonant instruments, shaping not only the continuation of life but also the quality of living. Another often overlooked gland is the pineal gland, a small structure within the brain that secretes melatonin. This hormone helps regulate circadian rhythms, the natural cycles of sleep and wakefulness tied to the light and dark of the world outside. The pineal gland is like a timekeeper, ensuring that the orchestra of hormones follows not only internal cues, but also the rhythm of day and night. Without it, sleep might become fragmented, and the sense of alignment with natural cycles would fade. When seen together, these glands reveal the elegance of the endocrine system. Each one plays its part, yet none acts entirely alone. The hypothalamus and pituitary send signals downward, adjusting the activity of thyroid. Feedback from these glands, in turn, travels upward, informing the hypothalamus and pituitary whether to increase or decrease their signals. This constant exchange ensures balance, preventing extremes. If thyroid hormones rise too high, signals are sent to slow down their release. If cortisol levels climb, feedback reduces stimulation of the adrenal glands. This looping communication is what keeps the orchestra in tune. The endocrine system's influence is not limited to isolated processes, but extends across systems. When stress arises, the adrenal glands not only increase cortisol, but also affect metabolism, immune activity, and cardiovascular function. When the pancreas adjusts insulin, it influences muscles, fat tissue, and the brain. When sex hormones rise during puberty, they alter growth, mood, and behavior, as well as reproductive organs. This interconnectedness demonstrates that the endocrine system is not a set of independent instruments but an ensemble that creates harmony across the body. Because the system is so interconnected, even small disruptions can ripple outward. An underactive thyroid may affect mood, energy, and even heart function. Excess cortisol may weaken immunity and alter weight distribution. Insufficient insulin results in diabetes, a condition that influences not just blood sugar but also wound healing, kidney function, and vision. These examples illustrate that when one instrument is out of tune, the whole orchestra feels the discord. Yet when balance is restored, harmony returns, and the body functions smoothly once more. It is remarkable to consider how quietly this system works. Most people go through life without noticing the constant adjustments of their glands. They may be aware of hunger or sleepiness, of energy or fatigue, but rarely do they think of the hormones behind these states. Yet without this hidden orchestra, life would lose its rhythm. Muscles would not contract properly, bones would weaken, blood sugar would drift dangerously, and reproduction would falter. The silence of the endocrine system is not the silence of absence, but the silence of perfect coordination. To reflect on the endocrine system is to appreciate the artistry of nature. It has arranged a network where each part contributes its own unique signals, where timing and balance are maintained without conscious effort, and where the whole is far greater than the sum of its parts. Just as music can soothe, energize, or inspire, hormones can calm the body into rest, prepare it for action, or guide it through growth. The orchestra plays continuously, even when one is unaware, ensuring that life flows smoothly, moment by moment. In essence, the endocrine system is a silent orchestra, unseen yet ever active. Its glands are instruments of balance, its hormones are the notes, and the body itself is the music. To know this system is to recognize the quiet harmony that sustains life, a harmony that continues without pause, carrying each person gently through the unfolding of time. 4. The pituitary gland, master of subtle commands. At the base of the brain, nestled in a small hollow of bone behind the bridge of the nose, lies a gland no larger than a pea. Despite its size, it holds authority over much of the body's hormonal activity. This is the pituitary gland, often called the master gland, because it directs the activity of so many others. Though small and unassuming in appearance, it sends out signals that ripple through the bloodstream, shaping growth, metabolism, reproduction, and balance. Like the conductor of an orchestra, it does not play every note itself, but guides other instruments, ensuring harmony is maintained throughout the system. The pituitary gland is connected closely to the hypothalamus, which lies just above it in the brain. The hypothalamus acts as a watcher and listener, detecting conditions in the body and relaying information to the pituitary. If something shifts out of balance, the hypothalamus releases hormones that instruct the pituitary to act. The pituitary then secretes its own hormones into the bloodstream, many of which stimulate other endocrine glands to produce hormones in turn. This chain of communication, from hypothalamus to pituitary to distant glands, ensures that adjustments are made with precision and that balance is never left unattended. The pituitary is divided into two parts, the anterior and posterior lobes, each with its own roles. The anterior lobe produces several important hormones, including growth hormone, thyroid-stimulating hormone, adrenocorticotropic hormone, follicle-stimulating hormone, luteinizing hormone, and prolactin. Each of these has its own targets and effects, but all originate from the same small cluster of cells. Growth hormone, for instance, influences nearly every tissue in the body, promoting growth of bones and muscles, regulating the metabolism of proteins, fats, and carbohydrates, and aiding in repair. Thyroid-stimulating hormone travels to the thyroid gland, prompting it to release hormones that control metabolic rate. Adrenocorticotropic hormone signals the adrenal glands to produce cortisol, which helps the body respond to stress. Follicle-stimulating and luteinizing hormones guide the reproductive system, controlling ovulation in women and sperm production in men. Prolactin, as its name suggests, stimulates milk production in the mammary glands after childbirth. The posterior lobe, while smaller, carries its own importance. It stores and releases hormones produced by the hypothalamus, such as oxytocin and antidiuretic hormone. Oxytocin plays roles in childbirth, stimulating uterine contractions, and also in bonding, influencing feelings of closeness and trust between individuals. Antidiuretic hormone, meanwhile, regulates water balance by signaling the kidneys to conserve water when the body is at risk of dehydration. These hormones act not only on the physical state of the body, but also on emotions and behavior, showing once again that hormones are not confined to the body alone, but also touch the mind. What makes the pituitary so remarkable is its reach. Though it produces only a handful of hormones, each one triggers cascades of events in distant organs. When it sends thyroid-stimulating hormone, the thyroid responds by releasing thyroxine, which in turn affects nearly every cell in the body. When it sends adrenocorticotropic hormone, the adrenal glands respond with cortisol, influencing metabolism, immunity, and stress responses. These cascades allow the pituitary to extend its influence far beyond its size, orchestrating harmony through indirect yet powerful pathways. The pituitary's activity is governed by feedback loops. When the thyroid releases thyroxine, rising levels of this hormone signal back to the hypothalamus and pituitary, telling them to reduce their stimulation. When cortisol levels rise, they also feed back to dampen further release of adrenocorticotropic hormone. These loops ensure that hormone levels do not spiral out of control, but instead remain within safe ranges. The pituitary listens as much as it commands, adjusting its signals based on the responses of the glands it oversees. This constant dialogue between brain and body ensures that balance is always maintained, even in the face of change. During childhood and adolescence, the pituitary plays a central role in growth and development. Growth hormone released during these years drives the lengthening of bones, the strengthening of muscles, and the overall increase in body size. If growth hormone is deficient, growth may be stunted. In adulthood, growth hormone continues to act, not by lengthening bones but by supporting tissue repair and metabolism. In this way, the pituitary remains active throughout life, shaping the body's development in youth and sustaining it in later years. Reproduction also depends heavily on the pituitary. The follicle-stimulating and luteinizing hormones it produces regulate the menstrual cycle, triggering ovulation and preparing the body for pregnancy. In men, they stimulate the testes to produce sperm and testosterone. These functions reveal how closely life itself is tied to the signals of this small gland. Without its commands, reproduction would not proceed, and the continuity of generations would falter. The pituitary's influence thus extends not only across an individual's body, but across the entire human species. The emotional and social dimensions of life are also touched by the pituitary. Through oxytocin, it shapes the bond between mother and child, deepening attachment during and after birth. Oxytocin also influences trust, empathy, and connection in relationships more broadly. The pituitary, therefore, does not merely regulate physical states, but also participates in the subtler dimensions of human experience. Its hormones ripple outward into emotions, weaving chemistry into the fabric of relationships. Despite its title as the master gland, the pituitary does not act in isolation. Its authority is shared with the hypothalamus, which senses changes in the environment and internal state. Together they form a partnership, with the hypothalamus as the observer and the pituitary as the executor. This partnership ensures that signals are not arbitrary, but are based on real needs. If the body is too cold, too thirsty, too stressed, or ready for reproduction, the hypothalamus detects these states and prompts the pituitary to act. The pituitary then carries out the orders, ensuring that the body responds appropriately. This cooperation highlights the interconnectedness of body and brain, showing once more that no part of the endocrine system operates alone. The story of the pituitary gland is a story of scale. It is small in physical size, yet vast in influence. It produces a limited number of hormones, yet each one affects countless processes. It acts locally, yet its reach extends across the entire body. It whispers its instructions in molecules, yet those whispers echo in growth, stress, reproduction, and emotion. It is a master of subtlety, demonstrating how great influence can arise from quiet, precise action. In the stillness of the body, the pituitary gland continues its work. It monitors, adjusts, and directs without rest. Each signal it releases is timed with care, each adjustment measured with precision. It does not seek attention or recognition, yet without it, the orchestra of glands would lose direction, and balance would fade. To understand the pituitary is to appreciate the quiet power of small things, the way a single point of control can shape the harmony of the whole. Thus the pituitary, hidden deep within the brain, remains the master of subtle commands. Its influence flows invisibly, yet it is felt in every breath, every heartbeat, every moment of growth and repair. It is the conductor of the body's orchestra, ensuring that life unfolds not in chaos but in order, not in dissonance but in harmony. 5. The hypothalamus, a bridge of balance. Deep within the brain, resting in a protected space just above the pituitary gland, is a structure that serves as both observer and messenger. This is the hypothalamus, a small but powerful region that links the nervous system and the endocrine system. It listens constantly to the body's signals, interpreting them, and then directs the pituitary gland to act in ways that restore balance. The hypothalamus is not a gland in the traditional sense, though it releases hormones. Rather, it is a true bridge, blending the swift electrical impulses of neurons with the slower chemical messages of hormones. It is both brain and endocrine system at once, a place where thought and physiology meet. The hypothalamus monitors the body's internal state with extraordinary precision. It measures temperature, watches levels of water and salts, tracks nutrients and glucose in the blood, and even responds to emotional states. If something drifts away from the narrow ranges that sustain life, the hypothalamus notices. Like a careful guardian, it does not allow extremes to persist. When body temperature rises, it signals mechanisms that promote cooling, such as sweating and widening of blood vessels. When temperature falls, it triggers shivering and constriction of blood vessels to conserve warmth. This constant adjustment shows the essence of its role, the pursuit of balance, or homeostasis. One of the ways the hypothalamus maintains this balance is through its connection with the pituitary gland. It produces releasing hormones and inhibiting hormones that travel directly to the pituitary. These signals tell the pituitary when to increase or decrease the release of its own hormones. For example, when the body needs more thyroid hormone, the hypothalamus secretes thyrotropin-releasing hormone, which instructs the pituitary to release thyroid-stimulating hormone. That hormone then travels to the thyroid gland, prompting it to produce thyroxine. When enough thyroxine is circulating, the hypothalamus senses the rise and reduces its signals, slowing the chain. This loop of command and feedback is a central feature of endocrine regulation, and the hypothalamus sits at its beginning. The hypothalamus also plays a crucial role in regulating hunger and thirst. Within it are centers that sense levels of glucose, fatty acids, and hormones such as leptin and ghrelin. When energy stores are low, signals of hunger arise, encouraging eating. When enough food has been consumed, signals of satiety quiet the urge. Similarly, when the body is short on water, the hypothalamus detects rising salt concentration in the blood and generates the sensation of thirst. Once water intake restores balance, the signal fades. These processes show how the hypothalamus integrates chemistry with perception, turning changes in blood composition into the feelings that guide behavior. Sleep and wakefulness are also influenced by the hypothalamus. It contains clusters of neurons that help regulate circadian rhythms, the natural cycles of activity and rest that align with the 24-hour day. These neurons respond to light detected by the eyes and communicate with the pineal gland, which secretes melatonin. At night, when light diminishes, the hypothalamus signals for melatonin to rise, easing the body into sleep. In the morning, light reduces melatonin and increases wakefulness. Through this mechanism, the hypothalamus synchronizes internal rhythms with the external world, ensuring that rest and activity follow the natural order of time. Beyond regulating physiology, the hypothalamus participates in emotional responses. It is connected to the limbic system, the part of the brain involved in emotion and memory. When stress arises, the hypothalamus activates the hypothalamic pituitary adrenal axis, a chain that culminates in the release of cortisol from the adrenal glands. This prepares the body to respond to challenge by mobilizing energy, raising alertness, and altering immune activity. When danger passes, feedback reduces the response, restoring calm. This shows that the hypothalamus is not only a regulator of basic needs but also a mediator of the body's reaction to the complexities of life. The posterior pituitary, though technically an extension of the hypothalamus, illustrates another way this bridge functions. Hormones such as oxytocin and antidiuretic hormone are produced in the hypothalamus and stored in the posterior pituitary until needed. When released, oxytocin influences childbirth and emotional bonding, while antidiuretic hormone preserves water by acting on the kidneys. Both are examples of how the hypothalamus produces signals that reach far beyond the brain, shaping physical states and social connections alike. It is remarkable to consider how much influence this small region exerts. Only a few centimeters across, the hypothalamus oversees temperature, appetite, thirst, sleep, stress, and reproductive cycles. Its position in the brain allows it to integrate information from both the body and the external environment. Nerve inputs bring rapid signals about conditions such as pain or temperature, while chemical inputs from the blood provide slower but equally important information about nutrients, hormones, and other factors. By uniting these two streams of information, the hypothalamus creates a complete picture and then responds with precision. During development, the hypothalamus guides many transitions of life. At puberty, it begins releasing gonadotropin-releasing hormone in regular pulses, which stimulates the pituitary to produce hormones that awaken the reproductive system. Without this trigger, puberty would not occur, and the shift from childhood to adulthood would remain suspended. Later in life, changes in hypothalamic function contribute to the gradual transition into aging, influencing sleep cycles, appetite, and hormone levels. These examples highlight that the hypothalamus is not only a regulator of daily stability, but also a director of life stages. The strength of the hypothalamus lies in its subtlety. It does not command with force, but with gentle signals, adjusting continuously. Most people never notice its activity, just as one rarely notices the fine corrections a sailor makes to keep a boat steady. Yet without it, balance would collapse. Temperature would drift dangerously. Hunger and thirst would lose direction. Sleep would become fragmented, and stress would overwhelm. Its quiet vigilance is what allows the rest of the body to function smoothly without conscious effort. To reflect on the hypothalamus is to see the body as a network of connections, not as separate parts. Here is the place where thought, perception, and physiology blend into one. A shift in blood chemistry becomes a feeling of thirst. A change in light becomes the pull of sleep. A moment of stress becomes a cascade of signals preparing the body for action. The hypothalamus demonstrates that the boundary between mind and body is not sharp but fluid, with signals flowing in both directions across the bridge it forms. In the stillness of life, when one is at rest or even asleep, the hypothalamus remains alert. It monitors blood, temperature, and environment, never ceasing its watch. It whispers to the pituitary, prompts glands into action, and eases them back into silence when balance is restored. It is small, yet it touches every corner of the body. It is hidden, yet it shapes both survival and experience. It is the bridge of balance, the quiet mediator between thought and chemistry, between the nervous system and the endocrine system. Through its vigilance, the body finds harmony, and life continues in steady flow. 6. Thyroid gland, keeper of metabolism. Resting gently at the front of the neck, just below the larynx, is a gland shaped like a butterfly. It spreads across the trachea, with two soft lobes joined by a slender bridge of tissue, quietly producing hormones that influence nearly every cell in the body. This is the thyroid gland, often described as the keeper of metabolism. Though it is small and often overlooked, it sets the pace for how the body uses energy, how warm or cool it feels, and how tissues grow and develop. Like a metronome in music, it establishes a rhythm, ensuring that processes unfold neither too quickly nor too slowly, but in steady time. The thyroid releases two main hormones: thyroxine, often called T4, and triiodothyronine, or T3. These molecules contain iodine, a mineral taken in through food and essential for their formation. Once released into the bloodstream, T4 and T3 travel throughout the body, entering cells and influencing metabolism. They regulate how quickly cells consume oxygen, how efficiently nutrients are converted into energy, and how tissues grow and repair. The amount of thyroid hormone present determines whether the body's internal fires burn briskly or gently. Too much, and the fires flare high, causing restlessness, rapid heartbeat, and weight loss. Too little, and the fires dim, leading to fatigue, sluggishness, and a sense of cold. The thyroid's task is to keep these flames balanced, steady enough to sustain life without exhausting it. The activity of the thyroid does not arise in isolation. It is guided by the pituitary gland through the release of thyroid-stimulating hormone, or TSH. When the hypothalamus senses that the body's metabolism is slowing, it instructs the pituitary to release more TSH. This hormone flows to the thyroid, encouraging it to produce and release more T4 and T3. As levels rise, the hypothalamus and pituitary sense the change and reduce their signals, easing the thyroid's activity. This feedback loop ensures that thyroid hormones remain within a narrow range, protecting the body from extremes. It is a fine example of the body's constant self-regulation, where no system is left unchecked. Beyond metabolism, the thyroid influences growth and development. During childhood, its hormones are vital for brain development, bone growth, and overall maturation. A deficiency in thyroid hormones early in life can lead to delayed growth and cognitive challenges, showing just how essential this gland is from the very beginning. In adults, thyroid hormones continue to support tissue renewal, muscle strength, and energy production. They also interact with other hormones, shaping fertility, mood, and cardiovascular health. The thyroid's influence is broad and subtle, touching nearly every function of the body, without ever drawing attention to itself. Calcium balance, too, is linked to this region of the neck. Embedded in the back of the thyroid are the parathyroid glands, 4 tiny nodules no larger than grains of rice. While separate from the thyroid, they often work in close partnership. The parathyroids release parathyroid hormone, which regulates calcium levels in the blood. Calcium is essential for muscle contraction, nerve conduction, and bone strength. When levels dip too low, parathyroid hormone prompts bones to release calcium, kidneys to conserve it, and intestines to absorb more. When levels rise too high, the hormone decreases, allowing calcium to settle back into balance. Though small, the parathyroid glands remind us that even the tiniest structures can carry immense responsibility for stability. The thyroid's role in metabolism also connects to temperature regulation. As its hormones determine how actively cells burn fuel, they also influence how much heat the body produces. This explains why an underactive thyroid often leaves a person feeling cold, while an overactive thyroid may cause excessive warmth and sweating. The thyroid, then, acts as a thermostat, adjusting the body's heat output to align with its needs. This subtle function is felt not as a conscious choice, but as a quiet background sensation, shaping comfort and energy levels throughout the day. Iodine, though needed in only small amounts, is crucial for thyroid health. Without sufficient iodine, the thyroid cannot produce enough T4 and T3, leading to enlargement of the gland in an attempt to compensate. This condition, known as goiter, was once common in regions where diets lacked iodine. Today, the addition of iodine to table salt has largely prevented such imbalances, but the connection reminds us that even trace elements in nutrition play vital roles in hormonal harmony. The thyroid depends on this partnership with diet, showing how the external world shapes internal balance. Emotion and mood are not untouched by the thyroid's influence. When thyroid hormones are deficient, fatigue and sadness may arise, blurring the edges of thought and dulling motivation. When they are excessive, anxiety, restlessness, and difficulty concentrating may follow. These shifts highlight the intimate link between hormones and the mind. The thyroid's reach extends beyond the physical, touching the way one feels, thinks, and experiences the world. It is another example of how body and mind are woven together by subtle chemical threads. During moments of increased demand, such as pregnancy, the thyroid adjusts its output to support not only the mother but also the developing child. Its hormones ensure that growth proceeds properly and that energy demands are met. This adaptability shows the gland's responsiveness to life's stages, shifting its activity to meet the needs of the moment. Later in life, as aging progresses, thyroid activity may change again, sometimes slowing, sometimes remaining steady, always influencing the body's pace. Through all stages, it continues its role as the quiet keeper of metabolism. To picture the thyroid at work is to imagine a gentle flame in a hearth, warming a home through the seasons. Too strong a blaze and the house becomes stifling. Too weak, and it grows cold. The thyroid keeps the fire steady, adjusting it with precision. Most people never notice its presence. Yet without its guidance, the body would lose its steady warmth and rhythm. It is a silent guardian, ensuring that the body's energy is neither wasted nor insufficient, but always balanced for the tasks of living. In the orchestra of glands, the thyroid plays a central role. It does not set the rhythm alone, but it provides the tempo, the underlying pace that guides all other functions. Growth, repair, emotion, and even thought flow in harmony with the thyroid's signals. Its presence is constant, its influence vast, and its silence profound. To understand the thyroid is to recognize the quiet forces that shape life from within, the unseen balance that allows every cell to thrive. The thyroid gland, resting lightly in the neck, is more than a structure of tissue. It is the keeper of metabolism, the guardian of warmth, the supporter of growth, and the subtle influencer of mood. It is small, yet its reach is immense, touching every moment of life. In its steadiness, it allows the body to move gracefully through the cycles of day and night, of activity and rest, of growth and renewal. It is a reminder that harmony often arises not from noise or drama, but from quiet constancy, from the gentle persistence of balance maintained with care. 7. Parathyroid glands, guardians of calcium. Tucked quietly behind the thyroid gland, almost hidden within its folds, lie 4 of the smallest glands in the human body. These are the parathyroid glands, each no bigger than a grain of rice. Their size may suggest insignificance, yet their function is absolutely essential to life. They serve as guardians of calcium, constantly monitoring its levels in the blood and adjusting them with great precision. Without their watchful presence, the delicate balance of calcium would quickly be lost, and with it, the steady rhythm of muscle contraction, nerve conduction, and bone strength. In their smallness lies a power that resonates across every system of the body. Calcium is more than a mineral stored in bones. It is a messenger in its own right. Every time a muscle contracts, whether in the arms and legs or in the chambers of the heart, calcium flows into muscle cells to trigger the movement. Every time a nerve sends a signal, calcium plays a role in the release of neurotransmitters that carry the message across synapses. Blood clotting, cell communication, and enzyme function all depend on calcium's availability. For these reasons, the concentration of calcium in the blood must remain within a narrow range. Too little, and muscles may spasm uncontrollably, nerves may misfire, and bones may weaken. Too much, and organs may calcify, kidney stones may form, and the heart's rhythm may falter. The parathyroid glands ensure that neither extreme persists. The primary tool of these glands is parathyroid hormone, often shortened to PTH. When calcium levels in the blood drop, the parathyroids release more PTH, setting into motion a series of adjustments that restore balance. PTH signals the bones to release some of their stored calcium into the bloodstream, ensuring immediate supply. It also acts on the kidneys, reducing the amount of calcium lost in urine and increasing the reabsorption of this precious mineral. At the same time, it stimulates the kidneys to activate vitamin D, which in turn enhances the absorption of calcium from food in the intestines. Together, these effects raise calcium levels, protecting the body from deficiency. When calcium levels rise too high, the secretion of PTH decreases, allowing the body to release excess calcium and restore equilibrium. This cycle of adjustment is constant, taking place in every moment of life. Whether one is eating, resting, or sleeping, the parathyroid glands remain attentive, measuring blood levels and adjusting their signals. They are like sentinels at a gate, ensuring that the flow of calcium remains steady, neither too restricted nor too abundant. Their responsiveness allows the body to handle fluctuations in diet, activity, and metabolism without ever straying far from balance. Most people never notice the work of these glands. Yet without them, life would be interrupted by sudden and dangerous instability. Bones serve as the great reservoir of calcium, storing the mineral in dense networks of tissue. PTH draws upon this store when needed, reminding us that bones are not static structures but living organs that exchange minerals with the blood. Each release of calcium from bone is balanced by rebuilding, guided by both PTH and other hormones such as calcitonin from the thyroid. This dynamic flow ensures that bones remain strong, while also supporting the constant demands of muscles, nerves, and other tissues. The parathyroid glands orchestrate this process with a quiet authority, maintaining harmony between storage and use. The connection with vitamin D adds another layer of importance to their work. Without sufficient vitamin D, the intestines cannot absorb calcium effectively, no matter how much is consumed in food. PTH compensates by increasing bone release, but over time, this weakens the skeleton. This is why sunlight, diet, and the parathyroid glands are linked in a partnership that sustains calcium balance. Sunlight helps the body produce vitamin D. Vitamin D allows calcium to be absorbed, and the parathyroids ensure that calcium levels remain stable. Each part is necessary, and together they form a system of resilience. Though the parathyroid glands act in silence, their influence touches every heartbeat, every breath, and every movement. The contraction of the diaphragm that draws air into the lungs depends on calcium. The rhythm of the heart that pumps blood through arteries depends on calcium. The ability to walk, to speak, to write, to rest, all are shaped by calcium's presence, regulated by the guardians behind the thyroid. In this way, their work is felt continuously, even if unseen. Disruptions in parathyroid function reveal the importance of their vigilance. When the glands become overactive, producing too much PTH, calcium levels rise excessively, leading to weakness, bone loss, kidney stones, and disturbances of the heart. When the glands are underactive, calcium levels drop, causing muscle spasms, tingling sensations, and difficulty in movement. These conditions, though rare, illustrate how finely tuned calcium balance must be, and how critical the parathyroid glands are in maintaining it. Even small changes in their function ripple outward into profound effects. The story of the parathyroid glands also reminds us that greatness is not measured by size. Each gland is tiny, easily overlooked in anatomy, yet together they carry a responsibility that no other organ can replace. They do not act with drama or force, but with gentle adjustments, milligram by milligram, maintaining a balance that sustains life. They are like quiet caretakers, guarding a treasure not for themselves but for the entire body. Without them, the harmony of muscles, nerves, and bones would falter. With them, stability is assured. To reflect on their work is to appreciate the intricacy of the body's design. Every movement of calcium, every adjustment of PTH, every interaction with bones, kidneys, and intestines reveals a system built for resilience. It is a system that allows for change while protecting against extremes, that adapts to diet, environment, and activity while preserving constancy. It is the parathyroid glands that guide this balance. Invisible, yet indispensable. In the quiet of the body, the parathyroid glands remain at their post. They listen to the blood, respond to shifts, and restore harmony before imbalance can take hold. They are guardians of calcium, keepers of stability, small but mighty in their task. Their vigilance ensures that the body moves with grace, that nerves fire with clarity, that the heart beats with rhythm, and that bones remain strong. They are a reminder that even the smallest parts of the body can carry the weight of life itself, silently and faithfully. 8. Adrenal glands, responders to life's demands. Sitting like small caps atop each kidney are the adrenal glands, two triangular organs that embody the body's capacity to adapt and respond. Though modest in size, they are central to the balance between calm and alertness, between rest and readiness. Their role is not limited to emergencies, though they are often remembered for the surge of energy they provide in stressful moments. More truly, they are steady companions, adjusting blood pressure, regulating metabolism, and guiding the body through daily rhythms. They are responders not only to crisis but also to the ordinary demands of life. Each adrenal gland has two distinct regions, each with its own function. Outer cortex produces steroid hormones that act gradually but powerfully, shaping long-term balance. Cortisol, one of its main products, is often called the stress hormone, though its role is much broader. It influences how the body uses carbohydrates, proteins, and fats, helping to regulate energy. It supports the immune system in moderation, suppressing excessive inflammation. It prepares the body to handle strain, ensuring that energy is available where and when it is needed. Another hormone from the cortex, aldosterone, helps regulate salt and water balance. By acting on the kidneys, it determines how much sodium is retained and how much is excreted, and with sodium goes water. This adjustment stabilizes blood pressure and fluid balance, a constant and essential background function. The cortex also produces androgens, weak sex hormones that supplement those from the gonads and play roles in development and mood. The inner part of the adrenal gland, the medulla, produces a different kind of hormone. Here, adrenaline and noradrenaline are released, chemicals that act quickly, preparing the body for immediate action. They raise heart rate, increase blood flow to muscles, dilate airways in the lungs, and sharpen focus. This is the classic fight or flight response, a surge that enables survival in moments of danger. Yet these hormones are not only for emergencies, they also help in moments of excitement, effort, or change, ensuring that the body can meet challenges with energy and clarity. Together, the cortex and medulla make the adrenal glands both steady regulators and rapid responders, capable of guiding both the long-term balance and the short-term needs of the body. The adrenal glands operate in close connection with the brain, especially through the hypothalamic pituitary adrenal axis, often shortened to the HPA axis. When the hypothalamus senses stress, whether physical or emotional, it signals the pituitary to release adrenocorticotropic hormone. This hormone travels through the blood to the adrenal cortex, prompting it to release cortisol. Cortisol then acts on tissues throughout the body, raising blood sugar, adjusting metabolism, and preparing the immune system. As levels rise, they feed back to the brain, signaling it to reduce stimulation, completing the loop. This system ensures that stress responses are strong when needed, but do not persist, unchecked. It is a cycle of activation and resolution, protecting the body both from strain and from excess. Daily rhythms also depend on the adrenal glands. Cortisol levels rise in the early morning, helping the body awaken and prepare for the day. They decline gradually through the afternoon, reaching their lowest point in the night, allowing rest and repair. This rhythm is tied to the body's circadian clock and helps synchronize energy with the cycles of light and darkness. Disruptions in this rhythm, such as irregular sleep or chronic stress, can disturb not only energy, but also mood, immunity, and overall health. The adrenal glands, then, are not only responders to sudden challenges, but also keepers of daily cycles, aligning the body with time. The effects of the adrenal glands reach into many corners of life. Aldosterone ensures that blood pressure remains stable, preventing dangerous swings in circulation. Cortisol influences memory, sharpening recall in moments of stress so that the brain remembers important details. Adrenaline heightens awareness, quickening reaction times when alertness matters most. Together, these hormones shape both body and mind, guiding not only survival but also adaptation to the subtle demands of living. Disorders of the adrenal glands, though not common, reveal their significance. Too little cortisol, as in Addison's disease, leads to fatigue, weight loss, low blood pressure, and vulnerability to stress. Too much, as in Cushing's syndrome, results in weight gain, high blood sugar, weakened bones, and fragile skin. Overproduction of aldosterone causes high blood pressure and low potassium, while deficiency disrupts fluid balance. Tumors of the adrenal medulla can produce surges of adrenaline, causing episodes of rapid heart rate, sweating, and anxiety. These conditions highlight how finely tuned the adrenal system must be, and how much depends on its steadiness. Yet for most people, the adrenal glands function silently, adjusting their output without notice. Every time a person rises from sitting to standing, aldosterone helps prevent a drop in blood pressure. Every morning, cortisol quietly lifts energy, easing the transition from sleep to wakefulness. Every time excitement quickens the pulse, adrenaline has played its part. Their influence is constant, though rarely felt directly. They remind us that much of balance is maintained beneath awareness. In the hidden depths of physiology, to reflect on the adrenal glands is to see how the body prepares not only for the extraordinary but also for the ordinary. They are there when danger appears, but also when one climbs stairs, speaks before a group, or laughs with friends. They manage the stress of illness and the joy of exhilaration. They regulate salt in the blood as faithfully as they guide survival in crisis. Their dual nature, both steady and swift, both gradual and sudden, makes them unique among glands. They embody flexibility, the capacity to meet life as it comes. In the quiet of the kidney's shelter, the adrenal glands work without pause. They measure, they release, they restore. They are always prepared, not anxious or restless, but steady in their watch. They allow the body to move from rest to action and back again, to face challenge without losing harmony, to rise with the sun and sleep with the night. They are responders to life's demands, both great and small, guardians of readiness and balance. Without them, the body would lack its resilience, its capacity to adapt, its steady rhythm of energy and calm. With them, life flows in balance, prepared for whatever comes. 9. The pancreas, balancing blood sugar. Nestled deep within the abdomen, tucked behind the stomach and alongside the curve of the small intestine, lies the pancreas, an organ with a dual nature. It works quietly in digestion, releasing enzymes into the gut to break down food, but just as importantly, it plays a central role in the endocrine system through its specialized clusters of cells known as the islets of Langerhans. The pancreas regulates blood sugar, ensuring that energy is available to every cell without ever drifting into dangerous extremes. This balance is essential. For glucose, the simple sugar that fuels much of life's activity, must remain steady in the bloodstream. Too much or too little can disrupt not only physical energy but also the clarity of thought, the steadiness of mood, and the rhythm of health. The pancreas serves as the body's quiet caretaker of energy, ensuring that glucose remains within a narrow and safe range. The pancreas produces two key hormones that work in partnership: insulin and glucagon. They function as opposites, yet together they create harmony. Insulin lowers blood sugar when it rises, encouraging cells throughout the body to absorb glucose and store it for later use. Glucagon raises blood sugar when it falls, signaling the liver to release stored glucose into circulation. This gentle push and pull prevents swings, keeping glucose levels steady no matter the time of day, the intake of food, or the demands of activity. The system is beautifully balanced, a constant dance between storage and release, guided by the whispers of hormones. After a meal, when carbohydrates are broken down into glucose, blood sugar begins to rise. This rise is sensed by the beta cells of the pancreas, which respond by releasing insulin. Insulin acts like a key, unlocking the doors of cells so that glucose can enter. Muscle cells take in glucose to use as fuel for movement. Fat cells store it for the future, and the liver converts excess into glycogen, a storable form of energy. As glucose leaves the blood and enters cells, blood sugar returns to its normal range. The process is so seamless that most people never notice the shift, yet without it, glucose would accumulate dangerously in the bloodstream. When hours pass without food, glucose levels begin to fall. In this case, the alpha cells of the pancreas release glucagon. This hormone signals the liver to break down glycogen back into glucose and release it into the blood. If fasting continues, the liver can also create new glucose from amino acids through a process called gluconeogenesis. These actions ensure that even during long periods without food, such as overnight, the brain and muscles continue to receive the energy they require. The coordination between insulin and glucagon demonstrates the elegance of hormonal balance, a partnership that sustains life without pause. The importance of this system is revealed most clearly in diabetes, a condition where insulin is deficient or ineffective. In type 1 diabetes, the beta cells of the pancreas are destroyed, leaving the body unable to produce insulin. Without this key, glucose cannot enter cells and instead accumulates in the blood, leading to high blood sugar. In type 2 diabetes, the body becomes resistant to insulin, requiring more of it to achieve the same effect. Over time, the pancreas struggles to keep up, and blood sugar control falters. Both conditions show how vital insulin is and how much depends on the pancreas's quiet vigilance. When its work is interrupted, energy balance unravels, and health becomes fragile. Beyond insulin and glucagon, the pancreas produces other hormones as well. Somatostatin, released from delta cells, helps regulate the release of both insulin and glucagon, ensuring that neither becomes excessive. Pancreatic polypeptide, secreted by another group of cells, influences digestion and appetite, linking the pancreas's endocrine role with its digestive function. Together, these hormones reveal that the pancreas is not a single-purpose organ, but a versatile guardian of both nourishment and balance. The pancreas also demonstrates the intimate link between food and hormones. What we eat becomes not only the fuel of the body, but also the trigger for hormonal responses. A meal rich in carbohydrates stimulates insulin, while fasting or exercise encourages glucagon. Protein and fat influence the pancreas in their own ways, guiding the mix of hormones released. This connection shows how closely life depends on the interplay between nourishment and regulation, between what enters the body and how it is managed within. The pancreas stands at this crossroads, ensuring that every bite of food is translated into steady energy. The brain depends especially on this stability. Unlike muscles, which can use fats as fuel, the brain relies almost entirely on glucose. A sudden drop in blood sugar can cause confusion, dizziness, or even loss of consciousness. A prolonged excess damages blood vessels, nerves, and organs. The pancreas prevents both extremes, keeping glucose in the range that allows thought to remain clear, memory to function, and awareness to persist. In this way, its influence extends beyond the physical body to the realm of mind, sustaining not only life but consciousness itself. Even during times of stress, the pancreas adjusts. Stress hormones such as cortisol and adrenaline tend to raise blood sugar, ensuring energy is available for action. The pancreas responds by modulating insulin and glucagon, preventing dangerous surges. Exercise, too, alters the balance, with muscles drawing in glucose more readily, prompting adjustments in insulin release. These examples show that the pancreas is always adapting, always listening, always shaping its signals to match the body's changing demands. In reflecting on the pancreas, one sees the importance of harmony. It does not allow sugar to rise unchecked, nor does it permit it to fall away. Instead, it maintains a steady middle ground, a balance that sustains every heartbeat, every breath, every thought. Its actions are continuous and quiet. Without it, energy would fluctuate wildly, and life would be unsteady. With it, stability is assured, and the body moves gracefully through the rhythms of day and night, of fasting and feasting, of rest and effort. The pancreas reminds us that balance is not about stillness but about movement within limits. Blood sugar rises and falls, but only within a safe range. Hormones push and pull, but always toward equilibrium. This balance is not static but dynamic, a constant adjustment that reflects the needs of the moment. It is the pancreas that ensures this dynamic stability, turning food into energy, fasting into survival, and stress into resilience. In the quiet of the abdomen, hidden from view, the pancreas continues its work. It listens to the blood, measures glucose with precision, and releases its signals in response. It coordinates with the liver, the muscles, the brain, ensuring that all receive what they need. It acts without pause, without recognition, faithfully sustaining life. The pancreas is the balancer of blood sugar, the guardian of energy, the silent mediator between nourishment and need. Its constancy allows the body to flourish. Its subtlety keeps the mind clear, and its steadiness ensures that life flows without disruption. 10. Sex hormones, rhythms of growth and renewal. From the earliest stages of development to the final years of life, sex hormones quietly guide the unfolding of the human body. They are not limited to reproduction, though that is one of their central tasks. Instead, they influence growth, mood, bone, strength, skin, hair, and even the rhythms of sleep. They are woven into the cycles of life, appearing first as faint whispers in childhood, rising in strength during puberty, and then shifting, ebbing, and flowing with the passing of years. They are subtle shapers of both the physical and emotional landscape, helping the body not only to create new life but also to renew and sustain itself. In males, the principal sex hormone is testosterone, produced mainly by the testes. In females, the primary hormones are estrogen and progesterone, produced largely by the ovaries. Both sexes produce all three hormones, though in different amounts, and all three influence many aspects of health. Their effects begin even before birth. During fetal development, testosterone shapes the growth of male reproductive organs, while in its absence, the female pattern emerges. These early influences set the stage for later life, laying down the foundations of identity and function. As childhood progresses, the levels of sex hormones remain relatively low, allowing growth to proceed steadily without the dramatic changes of puberty. Then, as adolescence approaches, the hypothalamus begins to release gonadotropin-releasing hormone in rhythmic pulses. This signal awakens the pituitary, which in turn releases luteinizing hormone and follicle-stimulating hormone. These travel to the testes or ovaries, stimulating them to produce testosterone, estrogen, and progesterone. The surge of hormones ushers in puberty, the great transformation that turns children into adults. In boys, testosterone drives the deepening of the voice, the growth of facial and body hair, the increase in muscle mass, and the enlargement of reproductive organs. It also influences mood and energy, sometimes giving rise to restlessness or intensity. In girls, estrogen guides the development of breasts, the widening of hips, and the onset of menstruation. Progesterone joins estrogen in shaping the menstrual cycle, preparing the uterus for potential pregnancy each month. Together, these hormones coordinate the rhythms of fertility, orchestrating the possibility of new life. Beyond reproduction, sex hormones affect many systems. Estrogen supports bone density, protecting against fractures, and helping to maintain skeletal strength. It influences skin, keeping it supple and resilient, and affects cholesterol levels, offering some protection to the heart. Progesterone has calming effects on the nervous system, contributing to a sense of balance during certain phases of the cycle. Testosterone maintains muscle mass and bone strength in both men and women, and it influences mood, drive, and vitality. These wide-ranging effects remind us that sex hormones are not confined to fertility, but are participants in the broader harmony of health. The rhythms of these hormones are cyclical. In women, estrogen rises and falls with the menstrual cycle, peaking before ovulation and declining afterward, while progesterone rises in the second half of the cycle. These shifts can influence not only the uterus but also mood, energy, and even sleep. In men, testosterone levels follow a daily rhythm, highest in the morning and declining gradually through the day. With age, levels shift again. In women, menopause marks the end of reproductive cycles, with estrogen and progesterone declining. This transition can bring changes in temperature regulation, mood, and bone strength. In men, testosterone declines more gradually, influencing muscle mass, energy, and emotional balance. These shifts reflect the natural course of life. Cycles of rise and fall, of growth and renewal. Sex hormones also shape the brain. Estrogen influences memory and learning, enhancing communication between neurons. Progesterone calms neural activity, promoting restfulness. Testosterone influences areas related to motivation and drive. These effects help explain why fluctuations in hormone levels can be felt not only in the body but also in thought and emotion. A surge of estrogen may bring clarity and energy, while a decline may bring fatigue or sadness. Testosterone may sharpen focus and vitality, while its decline may bring subtle changes in mood. The link between hormones and the mind is profound, weaving chemistry into experience. Fertility is perhaps the most visible role of sex hormones. In women, estrogen and progesterone prepare the uterus each month for the possibility of pregnancy, while also regulating the release of eggs. If fertilization occurs, these hormones support the early stages of pregnancy, maintaining the uterine lining and nurturing the developing embryo. In men, testosterone guides the production of sperm, ensuring the possibility of conception. These processes highlight the generative role of hormones, the way they shape not only individual health, but also the continuation of life itself. Yet even beyond fertility, the presence of sex hormones continues to matter. They support resilience in bones and muscles, help regulate metabolism, and contribute to emotional well-being. When levels decline with age, the absence is felt not only in reproduction but in strength, mood, and vitality. These changes are not failures but natural transitions, part of the rhythm of human life. They remind us that hormones are not static but dynamic, rising and falling, shifting as the seasons of life unfold. The influence of sex hormones extends into social and emotional life as well. Oxytocin, though produced by the hypothalamus and released by the pituitary, often works alongside sex hormones, deepening bonds between partners and between parents and children. Testosterone, estrogen, and progesterone interact with this system, shaping attachment, intimacy, and emotional connection. In this way, hormones participate in the bonds of family and community, guiding not only individual health but the fabric of relationships. To reflect on sex hormones is to recognize the breadth of their influence. They shape the body during puberty, sustain fertility in adulthood, and guide transitions in later years. They strengthen bones, influence mood, regulate cycles, and affect memory and energy. They are not merely reproductive signals but fundamental participants in the whole of health. Their rhythms are not linear but cyclical, rising and falling, adapting to the changing needs of life. In their constancy and their change, they reveal the deep connection between body, mind, and the passage of time. In the stillness of the body, sex hormones continue their work. They rise and fall in patterns, orchestrating cycles both daily and monthly, both youthful and aging. They sustain strength, shape emotion, and preserve balance. They are the rhythms of growth and renewal, guiding life through its stages with quiet authority. Though often unnoticed, their presence is constant, their influence profound. They remind us that life itself is rhythmic, a series of cycles that unfold not with abruptness, but with gentle continuity, carrying each person through the journey of existence. 11. Hormones of growth and repair. Throughout life, the body is constantly changing, renewing itself, and adapting to new challenges. Cells divide, tissues rebuild, wounds heal, and muscles strengthen after use. None of this occurs by chance. It is guided by a set of hormones devoted to growth and repair, signals that ensure the body not only survives but flourishes. These hormones are active from the earliest moments of life, shaping development in the womb, directing the rapid growth of childhood, sustaining repair in adulthood, and continuing their work even into old age. They are the architects and caretakers of the body, guiding the cycles of building and restoration. One of the most important of these hormones is growth hormone, produced by the anterior lobe of the pituitary gland. Growth hormone influences nearly every tissue, stimulating cells to divide, bones to lengthen, and muscles to increase in mass. During childhood and adolescence, it drives the remarkable expansion of the body, ensuring that bones grow taller and stronger, and that organs develop in proportion. Yet even in adulthood, when height no longer changes, growth hormone remains essential. It supports the repair of tissues, the replacement of cells, and the maintenance of muscle and bone. Without it, healing slows, energy diminishes, and the vitality of the body fades. Growth hormone does not act alone. It works partly by stimulating the liver to produce insulin-like growth factor 1, or IGF-1, a hormone that promotes growth in bones and tissues. IGF-1 enhances protein synthesis, encouraging cells to build new structures. Together, growth hormone and IGF-1 form a partnership that supports both development and repair, ensuring that tissues not only grow but also recover from daily wear. These signals are released in pulses, often during deep sleep, highlighting the connection between rest and renewal. When sleep is deep and restorative, growth hormone surges, fueling the repair of muscles, the healing of small injuries, and the strengthening of bones. Sleep, growth, and repair are thus bound together by hormonal rhythms. Another vital hormone of growth and repair is melatonin, produced by the pineal gland in the brain. Known as the sleep hormone, melatonin helps regulate circadian rhythms, rising in the evening to guide the body toward rest. But melatonin also has protective effects, acting as an antioxidant to reduce cellular damage and supporting the repair of tissues during sleep. By helping the body rest deeply, melatonin creates the conditions for growth hormone to act, making it an indirect but crucial participant in renewal. The nightly rise of melatonin is a signal not only for sleep, but for the beginning of the body's repair cycle. Thyroid hormones also play an essential role in growth and repair. Thyroxine and triiodhyronine regulate the pace of metabolism, ensuring that cells have the energy needed for building and renewal. During childhood, these hormones are vital for brain development and skeletal growth. In adulthood, they continue to influence the turnover of proteins, fats, and carbohydrates, supporting tissue maintenance. Without adequate thyroid hormones, growth slows, energy lags, and healing is impaired. Too much, and tissues may break down too quickly, leading to imbalance. The thyroid's steady tempo sets the stage for growth hormone and other signals to act effectively. Sex hormones, too, are participants in repair. Testosterone supports muscle mass and bone density, encouraging the body to rebuild after exertion. Estrogen helps preserve bone strength and influences skin, blood vessels, and connective tissues. Progesterone, with its calming effects, contributes indirectly by supporting restful states that promote healing. These hormones reveal that growth and repair are not limited to childhood but continue throughout life, guided by signals that shape strength, resilience, and recovery. The adrenal glands contribute through cortisol, often called a stress hormone. In moderate amounts, cortisol helps mobilize energy for repair and reduces excessive inflammation, which could otherwise damage tissues. After an injury, cortisol helps control swelling and directs the immune system's activity. Though too much cortisol over long periods can impair healing, its balanced presence supports the body's ability to recover. Once again, we see the principle of balance. Hormones are neither good nor bad in themselves, but beneficial when present in the right amounts and at the right times. Insulin, from the pancreas, also has a role in growth and repair. By helping cells absorb glucose, insulin ensures that energy is available for protein synthesis and tissue building. After exercise or injury, insulin supports the replenishment of glycogen stores in muscles and the repair of damaged fibers. Together with growth hormone and IGF-1, it contributes to the rebuilding that follows exertion, turning effort into strength. These hormones illustrate how growth and repair are not separate from everyday life but part of its rhythm. Each day, cells are replaced, muscles are rebuilt after use, and small injuries are healed. Growth hormone surges during sleep. Melatonin sets the stage for rest. Thyroid hormones provide energy. Sex hormones preserve strength. Cortisol controls inflammation, and insulin fuels the process. Together, they form a network of signals that ensure the body is not static but constantly renewing. The importance of these hormones becomes especially clear in times of healing. When a bone is fractured, growth hormone and IGF-1 stimulate new bone formation. Cortisol manages inflammation, ensuring that repair proceeds without excess damage. Insulin ensures cells receive fuel for their work. Melatonin and growth hormone, rising during sleep, accelerate recovery. The process is not the work of a single hormone but a coordinated effort, a symphony of signals that restore integrity. Even in aging, when growth slows, the role of these hormones continues. Though levels of growth hormone, sex hormones, and melatonin decline, they still contribute to repair and renewal. Their reduced activity partly explains why healing becomes slower with age, why bones may become fragile, and why muscles may weaken. Yet their presence, even in smaller amounts, continues to support life. Their rhythms shift, but their influence endures. This reminds us that growth is not only the rapid expansion of youth but also the quiet maintenance of later years, guided by the same fundamental signals. To reflect on the hormones of growth and repair is to appreciate the resilience of the body. At every moment, tissues are breaking down and being built again. Muscles tear slightly during exercise and are rebuilt stronger. Skin renews itself. Wounds close. Bones adapt to new stresses. All of this is guided by hormones, signals that ensure repair is not random but orderly, not chaotic but balanced. They embody the principle that life is not static but dynamic, always in motion, always renewing itself. In the silence of night, as sleep deepens, growth hormone rises, melatonin protects, and repair begins. In the activity of day, insulin fuels cells, thyroid hormones provide energy, and cortisol manages responses. The cycle is continuous, blending rest and action, breakdown and renewal. These hormones are the caretakers of life, ensuring that the body not only grows but sustains itself, not only survives but heals. They are the quiet architects of resilience, the unseen builders of strength, the keepers of renewal in every stage of life. 12. The pineal gland, the timekeeper. Deep within the brain, in a small groove between the two halves, rests a tiny structure shaped like a pine cone. This is the pineal gland, one of the most mysterious organs in the endocrine system, long associated with cycles of light and darkness, of waking and sleeping. Its size is modest, rarely larger than a grain of rice, but its influence extends to the rhythm of every day. The pineal gland is the body's timekeeper, guiding circadian rhythms and helping align the inner world with the world outside. Its principal tool is melatonin, the hormone of night, which rises as darkness falls and ebbs as dawn arrives. In this way, the pineal ensures that the body rests when it should and wakes with the sun, maintaining balance with the cycles of nature. The pineal gland responds to light, though it does not see light itself. Instead, it receives information from the eyes, which sense brightness and transmit signals through neural pathways to the brain. When the eyes detect daylight, the pineal is told to hold back melatonin. When darkness falls, the signal eases, and the gland begins to release melatonin into the bloodstream. This daily rhythm allows the body to anticipate the passage of time, aligning internal processes with the environment. The pineal thus acts as a bridge between the external world and the internal state, translating the presence or absence of light into a hormonal signal that touches every organ. Melatonin's role extends beyond simply inducing sleep. It fine-tunes the body's internal clock, the circadian rhythm, which influences temperature, blood pressure, hormone secretion, and even metabolism. In the evening, as melatonin rises, the body's temperature falls slightly, heart rate slows, and alertness declines. This prepares the body not just for rest, but for repair, as other hormones such as growth hormone are released during deep sleep. In the morning, as melatonin falls, alertness and energy return, aligning the body with the rising sun. This cycle repeats every day, forming the foundation for healthful living. When it is disrupted, as in jet lag or shift work, the body feels unmoored, out of sync with its environment. The pineal gland has long fascinated thinkers, scientists, and philosophers. Ancient cultures regarded it as a mystical organ, the seat of the soul, or the third eye, perhaps because of its central location in the brain and its connection to light and darkness. While modern science has clarified its role in melatonin secretion, a sense of mystery remains. The pineal seems to embody the link between the physical and the intangible, between biology and rhythm, between body and time. Its work is invisible, yet its effects are deeply felt in the cycles of energy, rest, and renewal. The secretion of melatonin follows a seasonal pattern as well as a daily one. In many animals, melatonin levels rise and fall with changes in daylight across the year, influencing reproduction, migration, and hibernation. In humans, the effects are more subtle, but still present. Shorter days in winter often bring longer periods of melatonin, which may influence mood and energy. This connection helps explain why some people feel more tired or subdued during the darker months, a condition sometimes known as seasonal affective disorder. The pineal gland, by tracking the length of nights, links human biology to the turning of the seasons, reminding us that we remain part of the natural world. Melatonin also serves as a protector. It is a powerful antioxidant, helping to reduce damage from free radicals that can harm cells. During sleep, when repair processes are most active, melatonin supports the preservation of tissues, protecting DNA and cellular structures. This protective role adds another layer of importance to the pineal's work, showing that it does not simply induce rest, but also supports restoration. By ensuring that sleep is both regular and restorative, the pineal gland helps preserve health across the lifespan. As with other hormones, balance is essential. Too little melatonin can make sleep difficult, leaving the body restless and unrefreshed. Too much can cause excessive sleepiness or disrupt natural rhythms. The pineal's role is not to flood the body with signals, but to release them in gentle, measured amounts, always aligned with time. This precision highlights once again the theme of the endocrine system: harmony through balance, order through subtle adjustment. The pineal gland also interacts with other hormones. Cortisol, produced by the adrenal glands, follows a daily rhythm opposite to melatonin, rising in the morning as melatonin falls and declining at night as melatonin rises. These paired cycles ensure that energy and rest alternate smoothly. Growth hormone, secreted during deep sleep, depends on melatonin to set the stage. Sex hormones, too, are influenced by circadian rhythms, with fertility and cycles linked to time. The pineal, by setting the rhythm of melatonin, provides the foundation upon which these other cycles unfold. Even aging reflects changes in the pineal gland. In childhood, melatonin levels are high, supporting long and deep sleep as growth accelerates. With age, production declines, and sleep often becomes lighter and more fragmented. This shift reveals how central the pineal remains throughout life, from the steady rhythms of youth to the gradual transitions of old age. Its decline is not a failure but part of the natural passage of time, showing once again the deep connection between hormones and the rhythms of life. In modern life, the pineal gland faces challenges that earlier generations did not. Artificial light, especially in the evening, can suppress melatonin, delaying sleep and disrupting circadian rhythms. Screens, lamps, and city lights extend daylight artificially, sometimes confusing the timekeeper within. This shows how sensitive the pineal is to its environment, always listening for signals of light and darkness. When those signals are blurred, rhythms lose their clarity. Yet when light and dark are respected, the pineal restores balance, ensuring restful sleep and steady wakefulness. To reflect on the pineal gland is to reflect on time itself. It reminds us that life is not continuous motion but a series of cycles, of activity and rest, of day and night. It translates the turning of the earth into the language of the body, aligning us with the world beyond ourselves. It demonstrates that health is not only about nutrition or strength but also about rhythm, about living in harmony with the passage of time. In the stillness of night, as darkness surrounds, the pineal gland releases its quiet signal. Melatonin flows into the blood, calming the body, dimming its inner lights, and inviting rest. In the brightness of morning, the signal fades, energy rises, and the day begins again. The cycle repeats, day after day, season after season, a rhythm as old as life itself. The pineal gland, small and silent, is the keeper of that rhythm, the timekeeper of the body. 13. Feedback loops, gentle self-correction. Within the human body, balance is not kept by rigid commands, but by constant adjustment, a flow of signals that rise and fall in harmony. This principle is most clearly seen in feedback loops, the gentle mechanisms that allow hormones to regulate themselves. Rather than driving processes endlessly in one direction, hormones often act in cycles, where their own effects bring about signals that reduce or increase their production. This design prevents extremes and keeps life within the narrow ranges where it can flourish. Feedback loops are the quiet guardians of stability, the self-correcting rhythms that give the endocrine system its elegance and resilience. The most common form is negative feedback, where a rise in a hormone or its effect signals the system to slow down. This is seen in the relationship between the hypothalamus, pituitary gland, and thyroid. When thyroid hormone levels are low, the hypothalamus releases thyrotropin-releasing hormone, which prompts the pituitary to release thyroid-stimulating hormone. This in turn activates the thyroid to produce more thyroxine and triiodothyronine. As these levels rise in the blood, they signal back to both the pituitary and hypothalamus to reduce their stimulation. The system thus prevents thyroid hormones from rising too high, correcting itself once balance is restored. This cycle continues daily, quietly adjusting without conscious effort. A similar loop exists in the regulation of cortisol, the stress hormone. The hypothalamus begins the chain by releasing corticotropin-releasing hormone, which prompts the pituitary to release adrenocorticotropic hormone, which then stimulates the adrenal glands. As cortisol rises, it feeds back to the pituitary and hypothalamus, reducing their signals. In this way, the stress response is activated when needed, but prevented from continuing indefinitely. Without such a loop, cortisol could remain high, straining the body with constant readiness. With the loop intact, balance returns after each challenge, allowing the body to recover its calm. Feedback loops also guide the regulation of blood sugar. When glucose rises after a meal, insulin from the pancreas lowers it by guiding cells to absorb sugar. As levels return to normal, insulin release declines, preventing blood sugar from falling too far. When glucose drops, glucagon rises, prompting the liver to release stored sugar. As glucose stabilizes, glucagon declines. Here, too, negative feedback ensures that swings are softened and balance is maintained. These loops demonstrate the body's ability to fine-tune itself, like a musician adjusting the pitch of a string until it is just right. Positive feedback, though less common, also plays a role. Unlike negative feedback, which corrects deviations, positive feedback amplifies them until a natural endpoint is reached. One example is childbirth. As labor begins, the hormone oxytocin stimulates uterine contractions. These contractions push the baby downward, stretching the cervix. The stretching sends signals to the brain, prompting the release of more oxytocin, which increases contractions further. This cycle continues, intensifying until birth occurs, at which point the loop ends naturally. Positive feedback is rare, used only in processes where amplification leads to a necessary outcome, but it shows another way hormones shape life's events. Another example of positive feedback occurs in breastfeeding. When an infant suckles, nerve signals reach the hypothalamus, prompting the release of oxytocin from the posterior pituitary. Oxytocin causes the milk ducts to contract, releasing milk. The more the infant suckles, the more oxytocin is released, and the more milk flows. This loop continues as long as feeding occurs, ending when the infant stops. In this way, positive feedback ensures that essential processes like birth and nourishment are not interrupted until they are complete. The beauty of feedback loops lies in their adaptability. They allow the body to respond to changes in the environment without losing stability. When heat rises, hormones adjust to conserve water and lower body temperature. When energy is scarce, signals shift to slow metabolism and preserve fuel. When stress comes, cortisol rises to provide energy, but feedback ensures it falls again afterward. These loops show that stability does not mean stillness. It means dynamic balance, where systems are always moving, yet always returning to center. Feedback loops also protect against disease. When they fail, imbalances arise. If thyroid hormones no longer suppress pituitary signals, excessive stimulation may cause hyperthyroidism, leading to restlessness, weight loss, and rapid heartbeat. If cortisol's feedback is impaired, stress hormones may remain high, weakening immunity and harming tissues. If insulin's effect is resisted, as in type 2 diabetes, blood sugar remains elevated despite feedback, causing long-term damage. These conditions reveal how essential the loops are, and how their gentle corrections preserve health. The loops also connect different systems, showing the unity of the body. The reproductive cycle in women depends on shifting feedback between the hypothalamus, pituitary, and ovaries. Rising estrogen at first inhibits gonadotropin-releasing hormone, but near ovulation it flips to stimulate it, creating a surge that releases an egg. Progesterone then rises, feeding back to restore inhibition, ensuring the cycle continues in rhythm. This interplay demonstrates how feedback can shift between negative and positive, depending on the stage, always guiding the body toward balance and renewal. Even at night, feedback loops continue their work. As melatonin rises, it signals the body to reduce wakeful hormones and prepare for sleep. In turn, the cycles of sleep influence the release of growth hormone, which feeds back to support repair. In the morning, as light reduces melatonin, cortisol rises, feeding back to wake the body. These loops between pineal, adrenal, and other glands create the daily rhythm of rest and activity, aligning the inner world with the turning of Earth. To imagine feedback loops is to imagine a gentle conversation within the body. Each gland speaks, but it also listens. Each hormone acts, but it also invites correction. The system is not rigid but fluid, capable of adjusting to the smallest changes. It is like a boat on the sea, constantly shifted by waves yet always steered back on course. Without feedback, the body would drift into extremes. But with it, life remains steady, adaptable, and resilient. In their quiet way, feedback loops embody wisdom. They remind us that balance is not about preventing change, but about guiding it, not about resisting movement, but about allowing it within safe bounds. They reveal that harmony comes from self-correction, from the willingness to adjust and return. The body's feedback loops are gentle self-corrections, ensuring that hormones never stray too far, that energy never falters for long, that life remains within the narrow paths where it can thrive. In the stillness of the body, feedback loops continue, unceasing. They adjust thyroid levels, steady blood sugar, calm the stress response, guide reproduction, and maintain rhythms of sleep and waking. They act in silence. Their influence shapes every moment of existence. They are the body's quiet wisdom, the self-correcting cycles that make balance possible, ensuring that life is not a rigid line but a graceful curve that bends always back toward harmony. 14. Homeostasis, the art of steady balance. The human body is a landscape of constant change. Temperature shifts with the environment. Glucose levels rise and fall with meals. Water moves in and out of cells, and countless reactions unfold every second. Yet, through all this motion, life depends on stability. The body must keep its inner world within narrow ranges, not by freezing it in place, but by adjusting continuously. This ability to remain steady amid change is called homeostasis, a word that means same state, though it is better understood as balance in motion. It is the art of steady balance, where hormones, organs, and systems work together to keep life within the boundaries where it can thrive. At the heart of homeostasis lies the principle of regulation. The body does not wait passively for conditions to drift far from normal, but senses even small changes and responds quickly. When body temperature rises, sweat glands release moisture that cools the skin. When it falls, muscles shiver to generate heat. When blood sugar climbs after a meal, insulin guides it into cells. When it drops, glucagon releases stored energy. Each adjustment is small, but together they maintain constancy. Homeostasis is not the absence of change, but the ability to respond, to restore equilibrium again and again. Hormones are among the most important tools of this regulation. They carry signals from one organ to another, ensuring that balance is maintained across distance. The hypothalamus monitors temperature, thirst, and energy, releasing hormones that direct the pituitary to act. The thyroid sets the pace of metabolism, adjusting the body's use of fuel. The adrenal glands prepare the body to respond to stress, while the pancreas stabilizes glucose. Each gland is part of a web of communication, where no signal acts alone, but always in relation to others. This network allows the body to respond not just locally but globally, aligning every system with the needs of the whole. Consider the example of water balance. Every cell requires the right concentration of water to function, neither swollen with excess nor shriveled by loss. The hypothalamus senses changes in blood concentration and signals the release of antidiuretic hormone from the pituitary. This hormone tells the kidneys to conserve water, producing concentrated urine when the body is at risk of dehydration. When water intake is abundant, the signal diminishes, and the kidneys release more water. This cycle operates continuously, ensuring that cells remain bathed in the right environment. protected from extremes. It is a simple process, yet it reveals the essence of homeostasis: sensing change, sending signals, and restoring balance. Another example is calcium regulation, overseen by the parathyroid glands. Calcium must remain within narrow limits for muscles, nerves, and bones to function. When levels dip, parathyroid hormone rises, drawing calcium from bone, conserving it in the kidneys, and enhancing absorption in the intestines. When levels climb too high, the hormone declines, and calcium returns to safe levels. This balance supports not only the skeleton, but every heartbeat and every nerve impulse. The guardianship of calcium is one piece of the larger tapestry of homeostasis, where each mineral, each nutrient, is held within bounds. Temperature control offers another illustration. The body must remain near 37 degrees Celsius, or 98.6 degrees Fahrenheit, for enzymes and cells to function. The hypothalamus serves as the thermostat, sensing internal temperature and directing responses. Heat prompts sweating and dilation of blood vessels near the skin, allowing warmth to dissipate. Cold prompts shivering and constriction of vessels, conserving heat. Hormones, such as thyroid hormone, also influence the rate of metabolism, adjusting the production of heat at its source. Through these combined mechanisms, the body remains steady despite changes in the environment, from summer's heat to winter's chill. Glucose regulation is equally central. The brain depends almost entirely on glucose for energy, and its levels must remain stable. After eating, the pancreas releases insulin, guiding glucose into cells for use and storage. During fasting, glucagon prompts the liver to release glucose, maintaining supply. Cortisol and adrenaline also influence glucose, raising it during stress to provide quick energy. Together, these hormones ensure that the brain and body never lack fuel, even as diet and activity fluctuate. The balance is delicate but reliable. Another example of homeostasis in motion. Homeostasis also extends to pH, the measure of acidity in the blood. Cells function only within a narrow pH range, around 7.4, and even small deviations can be harmful. The lungs help maintain this balance by adjusting carbon dioxide levels, while the kidneys regulate the excretion of acids and bases. Hormones influence these processes, coordinating them with other needs. This quiet adjustment keeps the internal environment stable, allowing the chemistry of life to proceed unhindered. What makes homeostasis remarkable is its adaptability. It does not hold the body in rigid sameness, but allows flexibility within safe limits. During exercise, heart rate rises, breathing deepens, and glucose and oxygen are consumed rapidly. Yet even as demands soar, homeostasis keeps blood pressure within range, maintains hydration, and ensures energy supply. Afterward, signals shift again, guiding recovery and rest. This adaptability allows humans to endure extremes, from deserts to mountains, from fasting to feasting, without losing equilibrium. Hormones are central to this adaptability because they act at a distance, coordinating multiple systems at once. A single hormone like cortisol influences metabolism, immunity, and blood pressure together, aligning them for the demands of stress. Insulin not only lowers blood sugar but also promotes fat storage and protein synthesis, guiding the body into a state of building. Thyroid hormones influence heart rate, temperature, and energy, setting the pace for all. This interconnectedness shows that homeostasis is not a series of isolated balances but a symphony of adjustments, where every note influences the others. When homeostasis falters, illness arises. High blood sugar, as in diabetes, damages vessels and nerves. Loss of calcium balance weakens bones and disrupts muscles, Impaired temperature regulation leaves the body vulnerable to heat stroke or hypothermia. Disrupted water balance leads to dehydration or swelling. These conditions show how narrow the path of health can be, and how carefully it must be guarded. Yet they also reveal the strength of the system. For most of the time, without conscious effort, balance is maintained despite challenges. Homeostasis is not limited to the body but extends into the rhythms of life. Sleep and waking, hunger and satiety, stress and calm, all are cycles of balance. Hormones such as melatonin, leptin, and cortisol ensure that these cycles follow natural patterns, keeping the body in tune with time. This broader view of homeostasis shows that balance is not only physical, but also temporal, aligning the individual with the day, the season, and the environment. To reflect on homeostasis is to see life as a dance between change and stability. The body does not resist change, but embraces it, adjusting with every step. Hormones are the choreographers of this dance, guiding muscles, organs, and cells into harmony. The art of steady balance is not to prevent motion but to allow it gracefully, ensuring that life flows without losing its path. In the stillness of the body, homeostasis continues. Signals rise and fall, hormones flow, organs respond, temperature steadies, glucose stabilizes, water balances, and minerals align. It is an art performed without awareness, a masterpiece of quiet regulation. Homeostasis is the reason the body can endure, adapt, and thrive. It is the silent guardian of life, the balance that holds every breath, every beat, every thought within the boundaries of health. 15. The harmony with the nervous system. The human body is guided by two great systems of communication, the nervous system and the endocrine system. Each has its own language, its own pace. The nervous system speaks in electrical impulses, rapid and precise, traveling through networks of neurons to send messages in fractions of a second. The endocrine system speaks in chemical messengers, slower and broader, releasing hormones into the bloodstream to reach distant cells over minutes, hours, or days. Though different in speed and style, these two systems are not separate but deeply connected, working together to maintain balance and guide life. Their harmony allows the body to respond to the moment while also sustaining long-term stability, creating a unity that is greater than the sum of its parts. The nervous system excels at immediacy. A sudden sound prompts neurons in the ear to fire, sending a signal to the brain, which processes it almost instantly. Muscles tighten, the heart may race, and attention sharpens. This rapid response is essential for survival, allowing the body to react to danger or opportunity in an instant. The endocrine system, by contrast, shapes the aftermath. Hormones like adrenaline prolong the state of readiness, while cortisol ensures energy is available for sustained response. The nervous system sets the spark, and the endocrine system keeps the flame steady. Together, they provide both speed and endurance, the quick reaction and the lasting adaptation. One of the most important bridges between the two systems is the hypothalamus. Nestled in the brain, it receives neural signals about the environment and internal state, then translates them into hormonal signals that influence the pituitary gland and beyond. When stress arises, the hypothalamus releases corticotropin-releasing hormone, which prompts the pituitary to signal the adrenal glands. Within moments, cortisol and adrenaline are released, influencing metabolism, immunity, and alertness. Here, nerves and hormones act in sequence, one triggering the other, a partnership that allows the body to move smoothly from thought to action, from perception to physiological change. This harmony is also evident in daily rhythms. Light entering the eyes sends signals through the optic nerve to the brain, informing the hypothalamus of the time of day. In response, the hypothalamus directs the pineal gland to adjust melatonin production, guiding the body toward wakefulness in the morning and sleep at night. The nervous system detects the environment, while the endocrine system aligns the body's cycles accordingly. Without this cooperation, circadian rhythms would drift, and the body would lose its synchrony with the world outside. Together, they keep the rhythm of life in step with the turning of Earth. The reproductive system provides another example of their connection. The nervous system perceives sensory information and emotional states, while the endocrine system regulates fertility through hormones such as estrogen, progesterone, and testosterone. During childbirth, nerve signals from the stretching of the cervix prompt the release of oxytocin from the posterior pituitary, which in turn strengthens contractions. During nursing, nerve stimulation from suckling triggers oxytocin release, allowing milk to flow. In these moments, nerves and hormones act hand in hand, one sensing, the other responding, creating a loop of communication that sustains life's most intimate functions. Even simple acts like eating involve both systems. The sight and smell of food trigger neural signals that prepare the stomach, releasing gastric juices. At the same time, the pancreas begins to release insulin, a hormonal signal that prepares cells to absorb glucose. The nervous system reacts quickly to the presence of food, while the endocrine system ensures energy is managed over hours. Their cooperation ensures that nourishment is not only consumed but also distributed, stored, and balanced. The immune system, too, is influenced by this partnership. Stressful thoughts processed by the brain can lead to hormonal changes that affect immunity. The nervous system perceives challenge, while the endocrine system adjusts the immune response, sometimes enhancing it briefly, sometimes dampening it over time. This link between mind and body, between thoughts and hormones, demonstrates how deeply the systems are intertwined. The nervous system carries perception, the endocrine system carries adaptation, and together they shape health. Their harmony also allows for learning and memory. The nervous system encodes experiences through patterns of neural activity, while hormones such as cortisol and adrenaline influence which memories are strengthened. Stress hormones can sharpen the recollection of important events, ensuring survival lessons are not forgotten. Sex hormones influence memory and cognition as well, altering the way the brain processes information. Here, hormones act as subtle guides to the nervous system's function, weaving chemistry into thought, memory, and learning. The differences in their pace create balance. The nervous system handles immediacy, a reflex to pull back from a hot surface, a heartbeat quickened in surprise, a decision made in a fraction of a second. The endocrine system provides continuity, a stable body temperature, a steady metabolism, the cycles of fertility, the rhythms of sleep. If life were only nerves, it would be reactive but unstable, darting from one moment to the next. If it were only hormones, it would be stable but slow, unable to react quickly enough to survive. Together, they provide both agility and steadiness, the ability to act in the moment without losing the long-term balance that health requires. When harmony falters, the effects are clear. If stress is prolonged, the nervous system remains alert, while the endocrine system continues to release cortisol, leading to fatigue, weakened immunity, and imbalance. If thyroid hormones decline, the nervous system slows as well, causing sluggish thought and movement. If insulin is ineffective, the nervous system suffers from lack of fuel, impairing concentration and energy. These disruptions show that the systems cannot be separated. Their health is shared, their balance intertwined. To imagine their partnership is to imagine an orchestra with two conductors. one guiding the tempo with quick gestures, the other shaping the mood with slower movements. The nervous system sets the pace. The endocrine system sets the tone. Each listens to the other, adjusting in real time, ensuring that the music of life remains in harmony. Their dialogue is constant, silent, and invisible, yet it is the reason the body can think, act, rest, and heal in seamless flow. In the stillness of the body, even in sleep, their harmony continues. Neurons fire, guiding breathing and heartbeat, while hormones adjust metabolism and repair tissues. In waking, they act together again, nerves sensing the world, hormones sustaining the response. This unity is the foundation of life, the balance between speed and steadiness, between spark and flame. The nervous system and the endocrine system are partners, two voices in one song, guiding the body with harmony that is quiet, constant, and profound. 16. Daily rhythms, hormones, and timekeeping. Life moves not only through space but also through time. The rising of the sun, the fading of daylight, the arrival of night, and the return of dawn all create a rhythm that has guided living beings for millions of years. Within the human body, hormones help align this external rhythm with the inner processes that sustain health. They act as timekeepers, rising and falling in patterns that match the cycles of day and night. These daily rhythms, also known as circadian rhythms, shape, sleep, and wakefulness, hunger and digestion, energy and rest, mood and alertness. They are the body's way of staying in harmony with the turning of Earth, ensuring that life unfolds in rhythm with time itself. At the center of this timekeeping lies the hormone melatonin, secreted by the pineal gland. Its rise in the evening signals the body that night has arrived, preparing for rest. As light diminishes, melatonin increases, lowering body temperature, calming alertness, and guiding the mind towards sleep. In the morning, when sunlight enters the eyes, melatonin levels fall, and wakefulness returns. This daily rhythm repeats without fail, giving structure to the cycles of rest and activity. It is one of the most familiar examples of hormones as timekeepers, yet it is only part of the larger pattern. Cortisol, released by the adrenal glands, follows its own rhythm, nearly opposite to melatonin. It rises sharply in the early morning, peaking soon after waking. This surge provides energy, sharpens focus, and prepares the body for activity. Through the day, cortisol gradually declines, reaching its lowest point in the late evening, allowing rest to take its place. This cycle, known as the cortisol awakening response, helps explain why mornings often bring alertness and vigor, while evenings bring calm and fatigue. The rise and fall of cortisol and melatonin together form the foundation of daily rhythm, one guiding wakefulness, the other guiding sleep. Other hormones follow daily patterns as well. Growth hormone is secreted in pulses during deep sleep, supporting tissue repair, muscle renewal, and overall restoration. Insulin sensitivity varies through the day, often higher in the morning, preparing the body to use energy efficiently. Testosterone peaks in the early morning, contributing to vitality and strength, then declines as the day progresses. Even thyroid hormones show subtle fluctuations, adjusting metabolism with time. These patterns reveal that nearly every system in the body is tied to daily rhythm, not random, but ordered, always moving with the cycle of time. The synchronization of these rhythms depends on light, the most powerful signal for the body's internal clock. Specialized cells in the retina detect not only images but also brightness, sending signals to the brain's suprachiasmatic nucleus, the master clock. From there, signals spread to the pineal gland and to other organs, aligning their activity with the cycle of day and night. Hormones then carry these signals throughout the body, ensuring that tissues and cells follow the same rhythm. The liver, muscles, heart, and even the immune system all show circadian patterns, guided by the timing of hormones. The body is not simply awake or asleep. It is in continuous dialogue with time, adjusting every process to the cycle of light and darkness. When rhythms are disrupted, the effects are felt deeply. Traveling across time zones causes jet lag, as the body's internal rhythms remain aligned with the old time, while the external world has shifted. Hormones continue to rise and fall on their original schedule. Over time, the body gradually resets, aligning melatonin, cortisol, and other signals with the new environment. Shift work poses an even greater challenge, forcing the body to stay awake at night and sleep during the day, often against its natural rhythms. In such cases, hormones struggle to align, and health can be strained. These disruptions show how deeply time is embedded in biology and how essential it is to live in harmony with it. Seasonal changes also affect rhythms. In winter, when days are shorter, melatonin levels may remain elevated for longer, influencing mood and energy. Some people feel this as a heaviness, a slowing, sometimes called seasonal affective disorder. In summer, longer days bring shorter nights of melatonin, often accompanied by higher energy. These shifts remind us that human rhythms remain linked to nature, even in modern life, and that hormones serve as the translators of the world's cycles into the body's inner language. Daily rhythms are not only about sleep and wakefulness, but about the timing of countless processes. Blood pressure rises in the morning, preparing the body for movement. Digestion follows a rhythm, with enzymes and insulin responding differently depending on the time of day. Immune function shows cycles, sometimes stronger at night, aligning with rest and repair. Even mental clarity and reaction times vary, often peaking in mid-morning and early evening. These patterns are not accidents, but the result of hormones rising and falling in time, setting the pace for every part of life. The wisdom of daily rhythms lies in their order. By rising and falling predictably, hormones allow the body to anticipate needs rather than merely react. Cortisol rises before waking, ensuring energy is ready. Melatonin rises before sleep, ensuring rest begins smoothly. Insulin sensitivity is higher when meals are likely, aligning digestion with eating patterns. This anticipation is what makes rhythms so powerful. The body is not caught by surprise, but guided gently into each part of the day, prepared for what is to come. Yet rhythms are not rigid. They adjust to the environment, allowing flexibility within balance. If one stays up late, melatonin shifts to accommodate. If meals are eaten at unusual times, insulin adjusts. If light is dimmed or brightened, cortisol and melatonin respond. This adaptability ensures survival, allowing life in many conditions while still maintaining order. It reflects the balance of the endocrine system as a whole, flexible yet steady, responsive yet stable. To reflect on daily rhythms is to see life as a tapestry woven with time. Hormones are the threads, rising and falling, crossing and returning, creating patterns of wakefulness, energy, hunger, rest, and renewal. Each day is a cycle, repeating but never identical, shaped by light, food, activity, and rest. The endocrine system ensures that this cycle continues smoothly, aligning inner processes with the world outside. In the stillness of night, melatonin flows, growth hormone surges, cortisol falls. In the brightness of morning, melatonin ebbs, cortisol rises, energy returns. The cycle turns again and again, a quiet rhythm beneath every breath and heartbeat. It is the harmony of time within the body, the daily rhythm guided by hormones, ensuring that life is not chaotic but ordered, not restless but steady. It is the art of timekeeping, silent and constant, aligning the human body with the timeless turning of the earth. 17. Hormonal changes in childhood and adolescence. From the very beginning of life, hormones shape growth and development. Even before birth, they guide the formation of organs, the growth of bones, and the laying down of structures that will sustain health for decades to come. At birth, the body is already a symphony of hormonal signals, each one contributing to the steady rhythm of survival. In childhood, hormones continue to guide growth, ensuring that bones lengthen, muscles strengthen, and the brain matures. Then, as adolescence approaches, a new wave of hormonal change begins, reshaping the body and mind in profound ways. These changes are both subtle and dramatic, unfolding over years, yet they are all carried by the quiet work of hormones. During early childhood, growth is steady and guided primarily by growth hormone from the pituitary gland and thyroid hormones from the thyroid gland. Together, they set the pace of development, ensuring that height increases gradually and organs grow in proportion. Insulin also plays a key role, delivering energy to cells and supporting the building of tissues. These hormones maintain the rhythm of growth, not too fast and not too slow, allowing the body to develop steadily. The parathyroid glands regulate calcium, strengthening bones and teeth, while adrenal hormones help the body adapt to daily activity. Each of these hormones contributes to the foundation upon which later changes will build. The brain also develops under the guidance of hormones. Thyroid hormones are especially important in early life, influencing the growth of neurons and the connections between them. Without adequate thyroid hormone, mental development can be delayed, showing how essential these signals are from the very start. Growth hormone also contributes to brain health, supporting learning and memory, while insulin delivers the glucose that neurons depend on for energy. Even in the earliest years, hormones work not only on the body but on the mind, guiding both physical and intellectual growth. As childhood progresses toward adolescence, the adrenal glands begin to play a new role in a process called adrenarche. They start to release increased amounts of weak androgens, hormones that will later contribute to the changes of puberty. These signals cause the first appearance of pubic and underarm hair and subtly influence mood and energy. Though modest at first, these changes mark the beginning of the transition toward adulthood, a reminder that hormones always act in rhythms, building gradually before larger shifts occur. Puberty marks the most dramatic hormonal change of adolescence. The hypothalamus begins to release gonadotropin-releasing hormone in pulses, waking the pituitary gland, which in turn releases luteinizing hormone and follicle-stimulating hormone. These signals travel to the gonads, the ovaries in females and testes in males, prompting them to produce estrogen, progesterone, and testosterone. These hormones reshape the body, guide fertility, and influence mood, bringing about the transformation from child to adult. In boys, testosterone drives the deepening of the voice, the growth of facial and body hair, the increase in muscle mass, and the enlargement of the testes and penis. Growth hormone and thyroid hormones work alongside it, producing the adolescent growth spurt, where height increases rapidly over a few years. Bones lengthen, muscles strengthen, and the body takes on its adult proportions. Testosterone also influences the brain, contributing to energy, drive, and sometimes restlessness or intensity. These changes are gradual but profound, the unfolding of a new stage of life under the guidance of hormones. In girls, estrogen shapes the development of breasts, the widening of hips, and the maturation of the uterus and ovaries. Menstruation begins as estrogen and progesterone establish a monthly cycle, preparing the body for the possibility of pregnancy. Like boys, girls also experience a growth spurt, with bones lengthening and the body reaching its adult height. Estrogen strengthens bones and influences fat distribution, leading to the curves of the adult female form. Progesterone adds balance, preparing the uterus each month and influencing mood and calmness. These hormones do more than shape fertility. They influence the skin, the hair, the brain, and even the rhythms of sleep. Puberty also brings changes to the emotional landscape. Hormones influence neurotransmitters in the brain, altering mood, energy, and sensitivity. The ups and downs of adolescence are partly the result of these shifts. As the body adapts to new rhythms, estrogen and testosterone both influence dopamine and serotonin, neurotransmitters linked to motivation and mood. Cortisol, the stress hormone, may also rise more easily during adolescence, adding intensity to emotions. These changes remind us that hormones shape not only the physical body but also the experience of being human, influencing thoughts, feelings, and relationships. The timing of puberty varies, influenced by genetics, nutrition, and environment. Some children enter it earlier, others later, but in all cases, it reflects the awakening of the hypothalamus-pituitary-gonad axis, a system that remains quiet through childhood and then suddenly surges into activity. This awakening is a remarkable moment in life, the body's way of preparing for reproduction and adulthood. Once begun, the process unfolds steadily, each year bringing new changes until maturity is reached. Throughout adolescence, growth hormone and thyroid hormones continue to act, supporting the rapid changes of puberty. The bones grow longer, the muscles stronger, the organs larger. By the end of adolescence, growth plates in the bones close, and height stabilizes. The focus of hormones shifts from growth to maintenance, from building the body to sustaining it. Yet the echoes of adolescence remain, as the patterns of fertility and cycles of sex hormones continue throughout adulthood. These years are a time of transition, guided entirely by the rise and fall of hormones. From the first subtle changes of adrenarche to the dramatic surge of puberty, hormones direct the transformation with quiet precision. They are not always felt directly, but their effects are unmistakable, shaping the body, the mind, and the emotions. They turn children into adults, preparing them for the responsibilities of reproduction, the challenges of maturity, and the continuation of life itself. To reflect on childhood and adolescence is to see the power of hormones as shapers of life stages. They are not simply chemicals but guides, carrying the wisdom of timing, knowing when to awaken, when to accelerate, and when to slow. They ensure that growth is not random but ordered, that development is not chaotic but harmonious. From the steady rise of growth hormone in childhood to the surges of estrogen, progesterone, and testosterone in adolescence, hormones carry the rhythms of change, leading the body through one of life's most profound transitions. In the quiet of the body, even as the outer world changes rapidly, hormones work in steady cycles. They whisper to the bones, to the muscles, to the brain, guiding them to grow and mature. They shape not only height and strength but also thought and emotion, turning childhood curiosity into the complexity of adulthood. They are the unseen companions of growth, the silent architects of development, the gentle guides of life's unfolding journey. 18. Hormones in adulthood. Subtle shifts. Adulthood is often seen as a time of stability. The dramatic growth spurts of childhood and adolescence have ended. The body has reached its full height, and the cycles of puberty have matured into steady rhythms. Yet beneath this surface of balance, hormones continue to guide countless processes, quietly adjusting metabolism, reproduction, mood, and energy. Their influence is no less important in adulthood than in earlier years, though their shifts are more subtle. They sustain strength, regulate cycles, and adapt the body to the changing demands of work, stress, and family life. Even as growth slows, repair and renewal remain constant, carried by the steady flow of hormones. In young adulthood, sex hormones often play a central role. In women, estrogen and progesterone regulate the menstrual cycle, preparing the body each month for the possibility of pregnancy. Estrogen supports bone strength, skin elasticity, and cardiovascular health, while progesterone provides balance, promoting calm and preparing the uterus for implantation. In men, testosterone sustains sperm production, muscle mass. Both men and women rely on these hormones not only for fertility but for overall well-being. Their effects extend to mood, energy, and even the clarity of thought, showing how reproduction and general health are intertwined. Growth hormone, though less prominent than in adolescence, continues to act in adulthood. It supports tissue repair, muscle renewal, and metabolism, particularly during sleep. It helps the body recover from exercise, heal from minor injuries, and maintain lean mass. Alongside it, thyroid hormones set the pace of energy use, ensuring that the body's metabolism remains balanced. Together, they keep the body strong, resilient, and responsive to daily demands. The adrenal glands also play a continuous role, producing cortisol and aldosterone. Cortisol rises in the morning to prepare for activity, then falls at night to allow rest. It helps the body manage stress, regulates blood sugar, and influences immune function. Aldosterone maintains blood pressure and fluid balance, allowing the body to adapt to changes in hydration or activity. These hormones provide resilience, allowing adults to meet challenges, recover, and adapt without losing equilibrium. Insulin, secreted by the pancreas, continues to be one of the most important regulators of adulthood. It ensures that glucose from food is absorbed into cells, providing fuel for muscles, brain, and organs. Its delicate balance with glucagon prevents extremes, sustaining energy through both feasting and fasting. In adulthood, lifestyle choices such as diet and activity begin to influence insulin more strongly, showing the deep connection between daily habits and hormonal balance. When insulin functions well, energy remains stable. When resistance develops, as in type 2 diabetes, imbalance emerges, affecting not only metabolism but long-term health. Adulthood also brings subtle changes in circadian rhythms. Melatonin continues to rise at night, guiding sleep, though its levels may gradually decline with age. Cortisol follows its daily cycle, rising in the morning and falling in the evening, aligning energy with the day's light. These rhythms influence not only sleep, but also digestion, mood, and immune function. A well-aligned rhythm supports health, while disruption can bring fatigue and imbalance. Thus, hormones remain the body's timekeepers, even in adulthood, ensuring that inner processes follow the cycles of nature. Stress plays a greater role in adulthood, and with it, the hormonal systems that manage stress become increasingly important. Cortisol and adrenaline provide energy during times of challenge, while feedback loops ensure that they fall once the challenge has passed. When stress is chronic, however, these hormones may remain elevated, straining the body. Sleep may be disrupted, immunity may weaken, and metabolism may shift. Adulthood often requires navigating this balance, learning how to allow hormones to rise when needed, but also how to let them fall, restoring calm and repair. In women, adulthood eventually brings the transition of menopause, when estrogen and progesterone production from the ovaries declines. This transition, often occurring in midlife, marks the end of fertility, but not the end of hormonal influence. Estrogen and progesterone continue to affect bones, heart, and mood, and their decline shifts the balance of health. Hot flashes, changes in sleep, and mood fluctuations reflect the adjustment of the body to new levels of hormones. Yet even after this transition, the adrenal glands and fat tissue produce small amounts of estrogen, sustaining some of its protective effects. Menopause is not an ending but a change, a new balance that the body gradually learns to sustain. In men, testosterone declines more slowly, often beginning in midlife and continuing gradually. This change, sometimes called andropause, may bring shifts in energy, muscle mass, and mood. Yet testosterone continues to influence health throughout adulthood, supporting bone density, vitality, and emotional steadiness. Its decline is not abrupt but gradual, allowing adaptation. Like women, men experience a new balance rather than a sudden absence, a reminder that hormones are always in motion, adjusting to life's stages. The immune system also shifts with hormones in adulthood. Estrogen enhances some immune responses, while cortisol moderates them, preventing excess. Growth hormone and thyroid hormones support repair and recovery after illness. These interactions show that immunity is not separate from the endocrine system, but part of the same network of balance. Hormones help the body respond to threats, while preventing damage from overreaction, sustaining health across the years. Adulthood highlights the importance of lifestyle in shaping hormones. Sleep supports growth hormone and melatonin. Activity influences insulin and cortisol. Nutrition affects thyroid function and sex hormones. Stress management influences adrenal balance. Unlike childhood, where growth is largely automatic, adulthood requires partnership between the body and choices. Hormones continue to provide the foundation, but how well they act depends on the environment in which they work. The harmony of adulthood is therefore both natural and cultivated, guided by hormones but supported by daily rhythms and habits. To reflect on hormones in adulthood is to see that stability is not the absence of change but the art of subtle adjustment. Hormones no longer drive rapid growth or dramatic transformation, but they sustain the body, adapt to stress, and prepare for the transitions of later life. They guide reproduction, repair, and renewal, influencing strength, mood, and resilience. Their shifts are quieter, but no less important, ensuring that the body continues to thrive. In the stillness of the body, adulthood's hormones flow in steady patterns. Growth hormone rises in sleep, cortisol greets the dawn, insulin steadies energy, estrogen and progesterone or testosterone sustain strength and vitality. They act not with drama but with constancy, not with sudden bursts, but with quiet rhythm. They remind us that adulthood is not a plateau but a dynamic balance, where hormones continue their work of guiding, sustaining, and adapting. They are the subtle currents beneath the surface of stability, the silent architects of resilience in the long middle years of life. 19. Aging and hormonal balance. As the years advance, the body undergoes gradual changes that reflect the passage of time. Muscles may soften, bones may thin, sleep may lighten, and energy may ebb more easily. Yet these changes are not signs of sudden decline but the natural result of shifting rhythms, many of them guided by hormones. Just as childhood is marked by growth and adolescence by transformation, aging is characterized by adjustment. Hormonal balance remains central to this stage of life, though the levels of certain hormones decline and the timing of their cycles changes. Aging is not the end of hormonal influence, but the emergence of a new equilibrium, one that sustains life in quieter ways. One of the earliest and most noticeable changes is the decline of growth hormone. In youth, growth hormone surges during sleep, fueling tissue repair, bone growth, and muscle development. With age, these surges diminish, and the total amount of growth hormone decreases. As a result, muscle mass may decline, fat may accumulate more easily, and healing may slow. Yet even in smaller amounts, growth hormone continues its work, supporting renewal, preserving strength, and sustaining repair. Its decline is gradual, allowing the body to adapt, though the effects can be felt in the changing pace of recovery and vitality. Sex hormones also shift significantly with aging. In women, menopause marks the most dramatic transition. Estrogen and progesterone from the ovaries decline sharply, bringing the end of reproductive cycles. This change influences not only fertility but also bones, heart, and skin. Without the protective effects of estrogen, bone density may decrease, raising the risk of fractures, and the cardiovascular system may face new challenges. The skin may lose elasticity, and sleep may become less steady. These changes reflect the broad reach of sex hormones beyond reproduction. Yet other tissues, such as the adrenal glands and fat, continue to produce small amounts of estrogen, softening the transition. Menopause is not an abrupt end, but a shift into a new stage of balance, where the body finds stability without monthly cycles. In men, testosterone declines more gradually, often beginning in middle age and continuing into later years. This slow decrease, sometimes referred to as andropause, may lead to reductions in muscle mass, bone strength, and energy. Mood and drive may shift, though the changes are often subtle and spread across decades. Like estrogen in women, testosterone continues to play a role in health, even at lower levels, supporting bones, muscles, and emotional steadiness. Its gradual decline illustrates how aging is less about sudden change and more about slow adjustment, a quiet reshaping of balance. The thyroid also shifts with age, though often in subtle ways. Some people experience a decrease in thyroid activity, leading to slower metabolism, fatigue, or changes in weight. Others may develop mild overactivity, which can strain the heart and bones. Because thyroid hormones influence nearly every cell, even small changes can ripple outward, affecting mood, energy, and cognition. Regular balance is key, and the thyroid's role in setting the body's tempo continues throughout life, though the rhythm may alter with age. The adrenal glands, too, show shifts. Cortisol, the hormone of stress and alertness, may lose some of its daily rhythm. Normally highest in the morning and lowest at night, cortisol may remain elevated later in the day with age, contributing to lighter sleep and reduced restfulness. This change illustrates the link between hormones and time, showing why older adults often experience changes in sleep cycles. At the same time, the body's ability to respond to acute stress may decline, leaving older individuals less resilient to sudden challenges. Yet the adrenal glands continue to play their role, helping maintain blood pressure, fluid balance, and energy. Melatonin, secreted by the pineal gland, declines steadily with age. This hormone, which signals night and promotes deep sleep, becomes less abundant, contributing to shorter and more fragmented rest. Older adults often fall asleep earlier, wake during the night, or rise before dawn, reflecting the altered rhythm of melatonin. These changes affect not only sleep but also the release of other hormones, since many depend on the cycles of night and day. Yet even diminished, melatonin continues to guide the body, aligning inner time with outer time, though the alignment may become looser with age. Insulin and blood sugar regulation also change with age. Cells may become less sensitive to insulin, requiring more of it to absorb glucose. This condition, known as insulin resistance, can lead to higher blood sugar and, in some cases, type 2 diabetes. These changes highlight the interplay between hormones and lifestyle, since diet and activity strongly influence insulin's effectiveness. With age, maintaining balance requires greater attention, but the underlying mechanisms remain the same. The pancreas signals, the hormones respond, and the body adjusts. Beyond these individual hormones, aging brings changes in feedback loops. The delicate cycles of communication between hypothalamus, pituitary, and target glands may become less sharp, leading to slower responses. Hormones may take longer to rise or fall, and their signals may be less precise. This does not mean the system fails, but that it works with a gentler rhythm. The body continues to regulate itself, though the corrections may be smaller or slower, reflecting the wisdom of age in preserving balance with less intensity. Aging also reveals the protective role of hormones. Estrogen supports bones and the cardiovascular system. Testosterone preserves muscle and vitality. Growth hormone fuels repair. Melatonin guards sleep, and cortisol manages stress. As these decline, the body becomes more vulnerable, not because it is weak, but because its guardians are quieter. Yet even in quieter forms, hormones continue to sustain life, and their influence remains profound. Aging is not the absence of hormones, but the adjustment to new levels, the finding of balance in a different range. These changes remind us that aging is not a failure of the body, but its natural unfolding. Just as childhood and adolescence had their rhythms, so too does aging. Hormones that once surged now flow more gently. Cycles that once repeated now fade, but the essence remains. The body adapts. It learns to live with less growth hormone, less melatonin, less estrogen or testosterone. It shifts its patterns of sleep, energy, and repair. It finds harmony in new ways, a quieter balance that still sustains health. To reflect on aging and hormones is to see continuity rather than decline. The same signals that guided infancy, childhood, and adolescence remain present, though altered in strength. They continue their work of balance, guiding metabolism, mood, and repair. Their influence is quieter but no less essential. They embody the wisdom of moderation, showing that life does not require the same intensity in every stage. Just as a river slows as it nears the sea but still flows with purpose, so too do hormones continue their journey, carrying the body gently through the later years. In the stillness of age, hormones remain faithful. Growth hormone rises in small pulses. Cortisol greets the dawn with gentler strength. Melatonin marks the night with softer signals, and sex hormones linger in reduced but steady presence. They are quieter companions, but they continue to sustain life, guiding the body through the art of aging. They remind us that balance is not lost but redefined, that harmony remains even when the rhythms change. Aging and hormonal balance together form the final chapter of the body's story, one of adaptation, continuity, and quiet strength. 20. Conclusion. The quiet harmony of hormones, from the first spark of life in the womb to the quiet closing chapters of age. Hormones have been the constant companions of the human journey. They do not shout, they do not force, yet their influence is everywhere. They are the gentle whispers that tell cells when to grow, bones when to strengthen, muscles when to repair, and the mind when to rest. They are the timekeepers of day and night, the guardians of balance, the architects of growth, and the quiet sustainers of health. In their constancy, they remind us that life does not unfold in isolation but in harmony, each part linked to every other by streams of invisible messengers. The story of hormones is one of connection. The hypothalamus listens to the state of the body and signals the pituitary. The pituitary passes instructions to the thyroid, the adrenal glands, the gonads, and beyond. The pancreas regulates fuel. The parathyroids watch over calcium. The pineal aligns time. Each gland, though small, contributes to the whole, like instruments in an orchestra. None acts alone, and each listens as well as speaks. Feedback loops tie them together, ensuring that signals rise and fall in balance, never straying too far. This network is not rigid but dynamic, adjusting in every moment to the shifting world inside and outside. In infancy, hormones set the foundations of growth, guiding the rapid development of the brain, bones, and body. In childhood, they sustain steady progress, ensuring that growth remains orderly and strong. In adolescence, they awaken new cycles, reshaping body and mind for adulthood. In the middle years, they sustain strength, fertility, repair, and resilience. In aging, they shift once more, quieter but steady, guiding the body to adapt to new rhythms. At every stage, hormones accompany life, not as rulers but as guides, steadying the path with invisible hands. Hormones do more than regulate the physical. They shape thought and feeling, influencing memory, mood, and even the bonds between people. Oxytocin deepens trust and connection. Cortisol sharpens attention in times of challenge. Melatonin draws the mind into rest. Testosterone, estrogen, and progesterone influence not only fertility but emotion, motivation, and clarity. These subtle effects weave chemistry into consciousness, showing that body and mind are not separate but joined. The quiet harmony of hormones reminds us that every heartbeat, every dream, every thought is part of the same whole. The beauty of hormones lies in their balance. Too much or too little, too soon or too late, and the harmony falters. Yet within narrow ranges, they sustain the body with grace. Insulin keeps glucose steady. Parathyroid hormone balances calcium. Thyroid hormones set the tempo of metabolism, and cortisol rises and falls with the day. The precision of this balance is remarkable, for it must be maintained against constant change. Food, stress, temperature, light, and time. Hormones are the guardians of this balance, adjusting ceaselessly, ensuring that the body remains steady no matter the world's fluctuations. To reflect on hormones is to reflect on resilience. Life is not a straight line, but a dance between change and stability. Hormones are the choreographers of this dance, allowing the body to move gracefully from one stage to the next, from stress to calm, from wakefulness to sleep, from growth to rest. They remind us that balance is not stillness but movement within safe bounds, a dynamic equilibrium that allows adaptation without collapse. It is through their harmony that life continues, steady yet flexible, rooted yet responsive. As the body ages, hormones shift, but they do not abandon. They continue their work in quieter ways, guiding repair, preserving strength, sustaining cycles of rest and waking. Their decline is not failure but adaptation, a new balance suited to later years. Just as growth hormone once surged in childhood and then softened in adulthood, so too do melatonin, estrogen, testosterone, and cortisol adjust their rhythms. The body learns to live with less, to thrive in gentler cycles, to find harmony in moderation. Hormones teach us that life is not about holding on to intensity but about adapting with grace. Throughout history, people have sought to understand hormones. Though the word itself is modern, ancient cultures sensed the rhythms of fertility, the cycles of sleep, the influences of mood. They attributed them to the movements of the stars, the turning of seasons, or the humors of the body. Today, science has revealed the molecules and pathways, the glands and feedback loops, Yet the mystery remains. For even with detailed knowledge, the harmony of hormones still feels like a quiet wonder, the invisible threads weaving body and mind, health and time, into a single fabric. The lesson of hormones is one of humility. We do not control them directly. They act beneath awareness, adjusting long before the mind can intervene. They remind us that much of life is sustained by forces unseen, by processes that work faithfully in silence. They are a testament to the body's wisdom, the intricate design that allows survival, growth, and flourishing. To know hormones is not to master them, but to appreciate their quiet constancy, their tireless guardianship of balance. In the end, the story of hormones is the story of harmony. They are the reason the body holds steady amid change, the reason life unfolds in stages, the reason health can be preserved across years. They are the silent partners of every moment, unseen yet indispensable, guiding with gentleness and care. To fall asleep reflecting on hormones is to enter a state of gratitude for the balance they sustain, the rhythms they maintain, the quiet order they bring. In the stillness of night, as melatonin rises, cortisol falls, and growth hormone surges, the body enters its cycle of renewal. In the brightness of morning, as melatonin ebbs and cortisol greets the dawn, the body awakens once more. Day after day, year after year, decade after decade, hormones continue their work. They are the quiet harmony of life, the unseen keepers of balance, the gentle messengers that guide the human journey from beginning to end.